Right. If there are any questions, feel free to ask them in Discord, and then we can maybe cover that already. I see we have some new people joining already. So once again, if there are any questions about the previous material that we covered last week or any of the labs from last week, feel free to add them on Discord, and then we can go over that. Right. Otherwise, we will just wait until we start the session in about 8 minutes when all other people have joined as well. So we're just waiting 3 more minutes until the start of the meeting. In case there are any questions, feel free to ask them in Discord, and we'll make sure to cover that. Do you guys hear me okay like this, or should I turn up the volume of my microphone? All right, awesome. So for the people that might not have seen this already, but during the complete lab, you will be able to find some flags here and there. And in the lab portal, there is a flag verification section where you can enter these flags, right? So the questions of the flags will be in the lab portal under the flag verification tab. And if you collect all the flags, there are currently 40 flags in the complete lab, you will also get a course completion certification at the end, right? So this is not the full certification, the exam certification, but it's a certification to show that you went through the complete course already, right? All right. So I believe most people have joined already. So let's start this session already, right? So welcome everyone to the second session of the Attacking and Defending Azure Cloud Advanced Edition of the October 2024 batch, right? So let's start this session by maybe doing a quick recap of what we did last time. And then afterwards, we will go into the new material and try out some of these labs as well. Right. So last time, we started by enumerating a website of the target organization or corporation, right? And we found an email address on that website, right? We used device code phishing to compromise the user Thomas, the user for which we found the email address, right? And we sent them an email with the device code in there, and the user Thomas signed into that, providing us complete access to their account, right? We obtained an access token and a refresh token, which allowed us to obtain persistent access to the account of Thomas, right? Even bypassing any multi-factor authentication if that would have been in use, right? We connected with the account of the user Thomas to the Azure ARM API, right? The Azure Resource Management API. And we found that the user Thomas has some kind of privileges on the GIS app vault key vault, right? So we enumerated what was in this key vault, and we found that there was a certificate in there. And the user Thomas actually had the privileges to export the certificate as well as a private key, right? And after further enumeration, we found that this certificate was actually an application certificate used by the GIS app. So we used that certificate that we extracted to authenticate towards Azure as the GIS app, right? Using the JWT assertion technique, right? In this case, we could also just have used the certificate directly to authenticate. However, we just learned the JWT assertion technique, so we used that instead, right? Then we found that the GIS app itself also has some kind of privileges, right? So we found that it also had access to a key vault, a different key vault, the data analytics app vault, right? Inside of here, there was also a certificate stored. However, GIS app did not have the permissions to export the private key, right? So it could read this certificate metadata, but it was not able to extract the private key. So here, our only option was to perform the JWT assertion technique, because GIS app did have read permissions over the certificate, but also sign permissions, right? So we could craft a JWT token and let that be signed by the data analytics app vault certificate, the certificate that was stored in there, using the signed permissions, which gave us a signed JSON web token, which we then used to forward that to Microsoft, resulting in an access token for the data analytics app, right? Because this certificate was once again a certificate used by an application. We enumerated all the applications, and we found that this certificate was used by the data analytics app, right? So this is where we were. We ended the previous session, right? So in this session, we're going to completely kill chain one. You see there is quite some stuff left, and then we will also hopefully start with the first learning objective of kill chain 2 as well, right? However, there was a lot of theory at the start of the first session. There will still be some theory now, right? Just because we want to cover the new techniques. However, there will be quite a lot more hands-on as well, right? So you should make some good progress. All right. So this is where we left off last time, right? Where we completed learning objective 2. We have a question already, so I'm going to cover that really quickly. Are we able to use JWT assertion technique to create token, for example, for the Microsoft Graph API with permissions that application does not have, is not consented to? No, because recall how the JWT assertion works. We are able to indeed craft a JSON web token, and we can put anything in there that we want, right? We can then sign that JWT assertion and forward that to Microsoft, right? But Microsoft is going to be the one, the token endpoint of Microsoft is going to be the one that will be validating everything that is in there still, right? So it does trust us a little bit, because it will check the signature of the data analytics app certificate, right? It will see that it matches that, so it will trust that the information is in there is somewhat correct, right? It will trust that it will come from the data analytics app, but it will not trust us that much in order to just forge whatever we want inside of the certificates and inside of the access token, right? So before it hands over the access token, it will still perform some checks and to see if the application actually has the required permissions that it is requesting, right? And otherwise it will not provide that, right? All right. So last time where we ended off here is with the an access token for the data analytics app, right? So we can create access tokens for the data analytics app, right? We'll see later on how we can use that to obtain access to a storage account, right? But before we do that, let's first cover some of the information that we will be needing later on, right? So attribute-based access control specifically is what we want to cover, right? So attribute-based access control, what is this? This is some kind of functionality that builds on top of resource-based access control or role-based access control on RBAC, right? And it provides even more fine-grained access control based on specific attributes, right? Where, for instance, with RBAC, you can provide access to a specific storage account, right? What you can do with ABAC is go even lower than that, right? So instead of giving access to a specific storage account and being able to list all the blobs in there, you can go a step further and use ABAC to only allow access to certain blobs that match a specific condition inside of that storage account, right? For instance, using something like tags, right? So let's say, for instance, that we have a storage account, but we have all kinds of information in there, all kinds of storage blobs in there, and we want to give a user access to some of the blobs in there, right? Based on which project they are working on based on which department they are from, right? Then we can use ABAC, for instance, to add tags to these kinds of blobs, to each blob that we want the user to get access to, right? And only allow the user to gain access to the blobs that match a specific condition, right? So if you see over here, in this example, right, from Microsoft, we can, for instance, create a tag named project and assign a condition to a permission where a user will be able to read all the blobs, but only if the blobs have the project tag set to cascade, for instance, right? So fairly simple. This is what ABAC allows you to do, right? So how can we potentially abuse this, right? Or in which specific use cases will we be able to abuse this, right? So in case there is a storage account and there are some ABAC conditions on there that allow a user to access specific blobs, but only if it has a specific tag. Right? So let's say, for instance, that we also have the permission to write the tags on all the blobs, then we would be able to add our own tag and make it so that the condition will evaluate true when we try to access a specific blob, right? So this could potentially be used to gain unauthorized access to specific data, even when it is not intended for that, right? So in certain use cases, you might see that this is used at a specific organization. And if you encounter this, you will now be able to know how you could potentially see if you can still get access to specific blobs, even though the ABAC doesn't really let you do that by itself, right? So let me actually show you that how that looks like in the portal itself, right? So if we go in the portal, let's actually go to storage accounts. And then I can show you an example of what that looks like, right? So ABAC is specifically used on the oil data store storage account that we will see later on, right? And where is this actually configured? It's configured as under the access control settings. Right, so if we go to all the role assignments, we will see that there will be quite a lot of role assignments. Right, a lot of them are inherited from the subscription, right? So for instance, administrators will have complete access on the subscription, on the owner access on the subscription. So this will also be inherited on all the resources and resource goes below that, right? So let's look specifically for the permissions that are not inherited, right? And here we have one. This permission is only granted on this specific resource, right? So what is provided here? So on the data analytics app, or the data analytics app application, right, has the storage blob tag modifier on the specific resource, right? So let's look at what the storage blob tag modifier does. It's just a custom role, right? So if we see what permissions this custom role actually provides us, is it will give us read access on the role assignments, as we can see over here. We will also be able to list the storage accounts. We have read access on the container itself, and we can list the containers, right? So we have read access on the storage account, right? And usually this should provide us access to all of the blobs, right? However, if we see on this last column, if I actually scroll up a little bit to see the name of that column, it's the condition column, right? We see this is configured for this specific role assignment, right? So let's actually see what condition is configured here. So this is where you will see when ABAC is in use, right? So we get read access to the blob. However, there's a specific condition assigned to that, right? So we only get read access to the blob or the application that we saw, the data analytics app application only gets read access to the blobs inside of there if there is a department tag on the blob which matches the geology value, right? So if the blob is from the geology department, which will be checked by the tags on the blob, then we will have access to that blob, right? So this is how that looks like in the portal. All right, before we go into the next learning objective, something else that we want to cover is application permissions, right? So we already know that Android applications need some permissions to access resources, right? So there are actually two types of permissions that an application can have. The first one is delegated permissions, right? Where the application by default doesn't really have access by itself. However, if a user signs into the application and it grants those permissions based for the user in the context of the user itself, then the application will be able to get some privileges inside of the context of the user, right? So if you make this concrete with an example, let's say, for instance, the files.read permission is allowed to be granted as a delegated permission, right? So what does that mean? That means that if a user signs in and grants consent for the mail.read permission, then the application will be able to read the mails, but only the mails from the user, right? Not mails from other users, right? However, if this is a high privilege permission, like being able to read the mails of the user, an administrator will most likely need to consent to that because otherwise users would easily be able to be phished using consent phishing, right? So user would need to provide consent for low privilege permissions. With high privilege permissions, like the ability to read the mails of the user, then admins will most likely need to provide consent to that, right? Unless you modify the default settings of that, right? The consent settings. Second type of permission that an application can have is application permissions, right? So that in this case, an application will be able to execute some actions within the context of the application itself without needing a user to sign into that, right? So for instance, the mail.read all, for instance, if that is a permission, it would allow a application to read the mails of all the users in the organization, right? Without needing for a different user to sign in, right? So it will be able to access the mails of everyone without needing a user to be signed in, right? However, since this is obviously a very high privilege, this needs to be granted admin consent manually, right? So these are the two types of application permissions, right? Um, from the Microsoft documentation, they say that application permissions should usually be granted if you find yourself in a scenario where you are tempted to store credentials credentials of an application or credentials of a user and allow the application to sign in as a user or administrator in order to retrieve some information, right? Uh, for instance, in our example previously, we could just as well create an administrator user who is allowed to read all the mails of all users, right? And then use the credentials of that administrator user in our application, right? But that wouldn't really be that best practice, right? It's better to grant some application permissions directly, right, to that application to allow it to retrieve the mails themselves without having to store the clear text credentials of a user account, right, or an admin account. So essentially, it allows an application to access APIs using its own identity, right? This is also called a role assignments, right? When an application signs in with delegated permissions, do the sign-in logs show the sign-in as the application or the user? That would actually be signed in as a user. So that will be shown in the sign-in logs of the user. So obviously, the possibility for an application to execute actions with its own identity is obviously something that is fairly useful for us as an attacker as well, right? For a lot of cases, right? Because applications will, it says rarely have MFA, but applications can't actually have MFA, right? But applications can have conditional access policies assigned to them, but it will rarely have any conditional access policies assigned to them. Why is that? Because conditional access policies are by default not enabled for workload identities or for applications, right? This is an additional license that you would need, right? So even if you have a P2 license, you would not have conditional access policies for your applications, right? You would need to have a specific extra license on top of that per specific application in order to enable or use conditional access policies on applications, right? If you are able to compromise the identity of an application, right, you would be able to use all of their permissions, right? And since conditional access policies are rarely allowed on that, it will be usually a lot easier to keep using the identity of that application for a long period of time without any detection, right? Because it will also usually not trigger any alerts either, right? So only on very rare instances there will be an alert when application permissions are being abused, right? So in the lab, there is an application named Geology app, which has quite a lot of permissions, which we will see later on, right? Is there a good way to enumerate these applications for misconfigurations? Well, that would depend, right? Because yeah, misconfiguration in the fact as if it is overly permissive, right? There are too much permissions assigned to an application, that you would need to check for per use case, right? Because a specific permission might be overprivileged for one application, however, another application might use that, right? So if you see something like, um, um, yeah, if you see that, for instance, authentication administrator role is assigned to an application. However, it only needs to read the properties of users, for instance. That would be a use case where the permissions are overly permissive, right? So it would depend on application to application, right? So in the end, it comes down to assigning least privilege permissions, right? Only assign the permissions that your application actually really needs, right? So that's what it would come down to, right? So that brings us to learning objective 3, right? Once again, this is where we are currently, right? So we have access to the data analytics app, right? And so let's actually sign in with the permissions of the data analytics app over here. Actually, one thing I want to show you in the portal, if we go to the conditional access policies, let's showcase you the conditional access policies for workload identities, right? So if you don't have the additional license that would allow you to um, use conditional access policies, this would not even show up, right? So this is a workload identities premium license that you require. So it is not included in a regular P2 license, right? So if you have that, then you can, for instance, by default it will be on users or groups, right? So you can select workload identities, right? And you can select several service principals that on which you would want to apply conditional access policies, right? For instance, an example, just take one, right? And there will be quite a lot of things that you can enforce, right? But it will be more limited as for users, right? Because as you will see, there is no way to enforce which type of client application it is signing into, right? It's not because applications will not use a browser, for instance, to sign in, right? So it will be a lot more limited, right? But things that are still very powerful are, for instance, allowing an application to only sign in from certain locations, right? So usually this is a very, very strong control because in a lot of cases, if you use an application identity, it will be signing in from a predictable location in most cases, right? So then you can, for instance, create a named location and only allow this application to sign in from a specific public IP address. For instance, if it's an application running on-premise and you know that will always be using your public IP address from on-prem, then you can allow only that, right? Also, the grant controls will be a little bit more limited, right? You can either block an application to gain access or grant it access, right? However, there is, as you can see, no option to require multi-factor authentication here, right? Instead of the creation of conditional access policy using workload identities, why should you not create conditional access policies using target resource? So this is a question that's being asked. That is because the target resource is the application where we are signing into, right? But it is not in the case of workload identities, the application is actually the identity that is signing in, right? So you can, for instance, create a conditional access policy if we go back and create a conditional access policy for users, right? For instance, we want our user to only be able to sign into the Microsoft Graph API from a specific location, then we would select the user here, right? But if we want our workload identity to only be able to sign in to the Microsoft Graph API from our on-prem public IP address, this is the only way you can do that, right? Indeed, it's the source that you're configuring here, right? And this is only possible if you have the additional license, right? Okay. Let's actually continue then with the learning objective, right? So I'm gonna quickly paste in some stuff from the last learning objective just to bring us back up to speed with the current, with where we were last time, right? So what are we doing here? Last time we had the certificate of the GIS app certificate stored, right? So we are importing this and requesting an access token with this certificate for the vault.azure.net API. Right, so this is what we're going to be doing with the JWT assertion technique, right? So we have our signed JSON web token over here, and now let's actually send that signed. 2 seconds. This is not the. So here we have the signed JSON web token, and now let's use that to request an access token from the for the ARM API, right, as the data analytics app ID, right? So it's a lot of commands because we're starting as a GIS app. Let me actually show you this over here, right? So we have the certificate of the GIS app, right? We are using that to obtain an access token for the Key Vault API. So that is what we did over here, right? And once we have the access token of the Key Vault API as the GIS app, we can now use the sign permission we have over the Key Vault, over the certificate in the Key Vault, to obtain an access token as the data analytics app, right, using JWT assertion. Right? So this is what's happening over here, but this brings us back to where we were last time, right, with the privileges of the data analytics app, right? And specifically, what access token that we request as a data analytics app, the management.azure.com, for the management.azure.com resource, right? So now we can use that to connect to with the Azure PowerShell module, right? Using that access token. This is what we did last time, right? So now we're connected as a data analytics app to the Azure PowerShell module, right? So let's see what permissions we have. AZ resource. We already looked into this a little bit last time, but we noticed that we have access to a storage account, right? The oil data store, right? However, if we check the role assignments, okay, if we check the role assignments that we are able to read, we see that we have the storage blob tag modifier permission over the storage account, right? So this is the one that I showed previously in the portal already, right? So you know this information a little bit, but now you can also see how we can enumerate that, right? And the condition that we were talking about, this is the ABAC condition. You can see over here, right? So there will be some other condition over here. You can just ignore that. It will not be visible in the portal either. This is just something that Microsoft adds. You can see there's an OR condition, and this is actually the condition that we saw in the portal, right? So we have the ability to read blobs, however, only if there is a tag on the blob with the department key and the value geology, right? All right. Let's also actually look at the direct permissions that we have over this specific storage account, the old data store, right? Because we know that we have the storage blob tag modifier, but what actual permissions does this give us, right? This is a custom role definition, right? So let's actually see what that gives us, right? the old data store, we're listing the permissions with a regular API call. And we see that, as we saw previously in the portal already, we have some read permissions on the management plane, but we're mostly interested in the data plane, right? So we have the blobs.read, the blobs/read permission, and the blobs text/write. So in theory, we should be able to read all the blobs. However, we can only do that if the condition is if the department is actually geology on the blob, right? And here, the first part, this is actually to show what specific permission it is targeting, right? So only this condition will only apply on the blobs/read permission and not on the text/write. So what does that mean? It means that we can only read blobs where the department is geology. However, the text/write is not actually limited, right? We can use the text/write on all the blobs, right? Meaning that we can change the tag on other blobs that we can't read in order to gain access to that. All right, so let's actually obtain an access token for the data analytics app. Now our access token is for the Azure Resource Management API, right? However, to interact with the storage account, we need an access token for the storage resource, right? So storage.azure.com is what we need. This is the resource that we will be interacting to if we want to actually read information, so read the data in the storage account, right? So again, using the assertion technique, we get a signed JSON Web Token and send that to Microsoft to obtain an access token for the storage.azure.com API, right? So now we have this access token, right? There are a couple of ways on how we can now actually read the data in there. Sadly, there is no command to provide an access token to the Azure PowerShell module, so we can't really use get easy or create easy storage context, for instance. We can't use all the modules from the Azure PowerShell module because it doesn't accept an access token as raw input. So we will need to do some raw API calls, right? So let's start by actually listing which specific containers there are in the old data store storage account, right? So we're using the access token that we just requested, and we're sending some basic API calls towards the storage account to list the containers in there. So let's see what containers are in there. We see there's one container named certificates, right? So now let's actually change that and actually try to view the actual content of that container, view the blobs in that container, right? So to do that, we just use the same URL. However, now we're adding the name of our container, so the certificates container, and now we're specifically asking the API to list the data in the container. Right? So let's see what we get. And it will be some random XML data. We will clean that up a little bit. You will see over here, it's not really very readable, and there will also be some garbage data at the start. So let's first remove some of the garbage characters and then list all the blobs in there with this command using some XML export queries, right? So we see that there are quite a lot of certificate attachments in there. Certificate attachment files in there. So these are all the blobs that are in there, right? So there will be one for all every single user to allow all of you to test and play with that, right? So for our user, since we are student user 6, let's try to access the certificate attachment 6 directly. And we'll see that we get an error, right? We are not authorized to perform this operation, right? Because this specific attachment or certificate attachment, this specific blob, will not have the specific tag, right? We need to have a tag with the department geology, right? So how can we do that? We can, since we have the permission to write a tag on all the blobs, you can use an API call. In this case, we're using a put request to actually add a tag on our specific blob that we want. And which tag are we adding there? So there's a little bit body that we will need to include in our HTTP request. And we will see that we construct a tag with the key name department and a value geology, right? So we send that API request. We will not get any output, but that means that it's good, otherwise it would have shown an error that we're not authorized to do that. Right, so and if we now do exactly the same thing as previously, try to read the actual content of that blob, we will see that we do not get any error and we actually get a certificate. Right. So we use quite a lot of PowerShell here to perform some API calls, so it can be a little bit annoying to work with that, right? So another way how we could have done that is using, for instance, GraphSpy, right? So let me show you another way that will make it a little bit more convenient. Our assertion is not valid anymore. Actually, that is fine because our access token will still be valid. So let's take our access token of the data analytics app for the storage API, and let's import that in GraphSpy. Right, so in GraphSpy, we used that previously to perform device code fishing and obtain access tokens and refresh tokens. However, you can also just manually import access tokens. Right? Maybe I give that a description. So you will see that all of the information of the access token will be visible over here. This is the application ID of the data analytics app, right? So we can now use that to send a custom API request as well, right? So as we did previously, the question is it possible to use GraphSpy with the key vault API? Yes, we'll show you an example how you can do it with the storage API, but you can use GraphSpy to interact with any API that you want, right? So that's what I'm going to show you, right? So the first request that we performed, right, we have activated this access token, or we have not. There we go. We have activated the access token of the data analytics app for the storage.azure.com resource, right? So now we can use that access token to send our API requests, right? So you just provide the URI in there. It's a GET request, right? And see what we get. Actually, we also need some headers, right? So let's add some headers in there, specifically the XMS version. It was all in the PowerShell that we did previously. And this one needs to be that. And there we go. We can just use GraphSpy to send these API requests as well, and it will automatically use the access token that we have stored in the database, right? And here we get some more neatly formatted output as well. We can see that there is a container inside the old data storage account named certificates, right? So let's say we want to reuse that for in the future, right? Maybe this time we are enumerating the containers of the old data storage account. What we can actually do is we can save this request as a template, right? So we can make the name of the storage account a variable like this, storage account. And then we can use these variables wherever we want, right? So now we're wanting to request the information of the all data storage accounts. So let's actually request that. So we'll see we get that output. And now we can save that as a template in the database for later use, right? So you can name that storage account list containers, for instance. Right, and then at a later point in time, we only need to modify this variable, and then we can just interact with this API, right? So I have already done this a little bit. So the next thing that we would be want to do is actually list the containers, right? So or list the actual content in the containers, right? So we would send a request to the certificates endpoint, and we want another parameter in there as type equals container, right? Send that request, and now we will see the content of all the blobs in the container, right? And we could once again add a variable in there, right? So that's what I've done over here. Once you have some request templates stored, you can just open one or select one that you want to use, and it will load all that information in there. So if you can see, we are listing the blobs in the container with the which container, the certificates container of the data, all data storage account, right? And the third request was to be able to list the blobs or list the actual information of a blob. So in this case, the blob that we're trying to read is insert attachment 6, right? So let's try to read that and we get our certificate as well, right? If we want to be able to modify the text, we can also do that with this request, for instance. And now we can just, for instance, set the department flag to something else. That's just to show you guys it is modified. If we now try to fetch the same blob as previously, we will see that we get the request as previously, right? So if we now try to set that once again, this is the same that we did in PowerShell, right? But it is a little bit easier to work with if you don't want to copy paste PowerShell code all the time, right? If we now try to change the tag, the department tag back to geology on the cert attachment 6, we can now see that we will get access to the certificate once again, right? So we can copy that and store that in a variable and continue in PowerShell, right? So just to show you another example, right? And you can build these kind of templates as well for any other resource that you want to interact with, such as the key vault API that was requested in the question. All right, so what do we do now? We were able to find this certificate, right? We stored that in a certificate variable over here, as you saw. So how do we know that this is a certificate? Well, we just assume that it's going to be a certificate. Why? Because as you see over here, it's a container named certificates, and the blob file name is named cert attachment 6, right? And if we look at the data, this looks very obviously base64 encoded data, right? So this is probably a base64 encoded certificate, right? So let's actually base64 decode that data to get binary data and then store that in a PFX file, right? That's what we did over here. So we will store that for later use. And let's actually see if it's a certificate, right? We assume that it's a certificate, but let's actually check if that is the case. So we can try to cast this PFX file to a certificate variable in PowerShell. And if we check the content of that variable, we will see that this is indeed a certificate. Right, so it has a thumbprint, it has a subject, and so forth, all things that you would see in a certificate, right? And we see the key usage will be for authentication, meaning that we can use the certificate to authenticate as well, right? So we have a certificate that we extracted from this key vault. What is the next step, right? So we can already assume that this certificate might probably be used by a application in Entra ID, right? We don't really know that, so let's actually enumerate that. So remember last time that we enumerated all applications in the old corporation tenant, right? We stored that data in an XML file. So let's now actually read that XML file and see if there is any application in the old corporation tenant where the key credentials or the key credentials object has a custom key identifier that matches the thumbprint of our certificate, right? So if we look at the thumbprint of our certificate is 58D9, right? We see that we get a hit, right? So we have one application that is actually using this certificate for authentication, right? So this certificate will be used by this application for authentication, right? You can also somewhat derive it from the subject, right? So it will be the name of the application. You will see the geology app. This is a certificate for the geology app, right? However, you don't really know for certain by just looking at the subject. Anyone can create a certificate with the subject, right? That doesn't mean anything, right? But if the thumbprint matches, then we know for sure that this is actually the certificate that we have here that we can authenticate as this geology app application, right? So let's do that right now. Let's connect with the certificate using the application ID. So this is here, and the certificate that we just enumerated, right? And we connect to Azure to see if we can access anything in Azure. So this is already a bad indication, right? We have no subscription, but just for completeness, let's check if we can access any resource. It will tell us we cannot access any resource because we don't have any access to any subscription, right? So it seems like we can't really access anything in Azure. So let's see if there is something we can access in Azure AD or Entra ID, right, by connecting to the Microsoft Graph API with the same certificate, right? So now we're authenticated as the Geology application to the Microsoft Graph API, right? Let's see what permissions that we have. You mistyped get easy resource. That's actually good that you mentioned that, get easy resource. That's why we use step completion. This is the actual error that you should have. Thank you, John, for mentioning that. So yeah, I was just expecting an error. I saw an error and then I went with it. But this is the actual error message. You have always read your error messages. So we don't have access to any subscription, so we can't. We don't have access to anything in Azure. Right? So we connect to the Microsoft Graph API, and let's actually see what permissions we have in Entra ID. Right? To do that, let's actually first check the service principal name, the service principal of the geology app, right, over here. And let's do some more enumeration, right? Why did we check that? Because we wanted the ID, not the application ID, we want the object ID, the service principal to do some more for a full comment, right? So we copy that object ID from the service principal name. What are we going to do here? We are going to list all the role assignments in Enter ID that this geology app may, for instance, have. And for each role assignment that we find, we will check the role definition, right? So we will take the ID, the role definition ID, and we will resolve that so that we can actually see a little deeper what this specific role actually is. We will resolve the names, the display names, the description, and the scope that is provided, right? So we see that our application has access to quite a lot of roles. So note these are Entra ID roles, right? So we have directory reader on the global directory scope. So this means that we can read everything in Entra ID. We also have the help desk administrator role on a specific administrative unit, right? So the directory scope will define where we can actually use these permissions, right? So help desk administrator, we can see that it can reset passwords of non-administrators. However, it is scoped to a specific administrative unit, so we can't just go around and reset everyone's password. We can only reset the passwords of this specific administrative unit. So what else do we have? Authentication administrator on a different administrative unit, right? So this one can reset passwords. This one can also reset multi-factor authentication information, right? And lastly, we also get application administrator on a specific object, right? This will probably be an application because the application administrator role allows you to do some stuff with app registrations and Entra apps, right? So it provides us some permissions on applications, right? The question is, in a production environment, does connecting to the tenant as an application cause any interruption or denial of service to the legitimate application? No, it will not, right? So because what actually happens if you sign in, you will just retrieve an access token and you can use that access token, right? But it will not invalidate any of the access tokens of the other application, right? The only reason I can think of that it could ever cause some issues is in case, for instance, there is a security team behind that and they are monitoring sign-ins of an application and they see a sign-in from a completely different IP address that they have never seen before and they freak out and they just, yeah, they try to take action to prevent any harm from that, right? So, but automated denial of service should not happen because you just sign in, right? Multiple access tokens can stay valid at the same time. The actual application will just keep using its actual access tokens that it received legitimately, right? So usually you shouldn't have to worry about that, right? So we see that this application is the Geo app application is quite overprivileged, right? Maybe it doesn't need all of these privileges, but probably they just assigned too much permissions over here, right? Help desk administrator over a specific administrative unit, application administrator over a different one, and application administrator. That's quite a lot, right? So these are intra-ID role assignments, right? However, there is a second type of permissions that an application might have. These are app role assignments, right, as we covered in the slides. This will allow an application to gain privileges over a different application, right? So these are Enter-ID role assignments. So it will give you some kind of access in Enter-ID. And you also have app role assignments giving you some type of access over a different application, right? So it seems like the Geology app, this is the service principal ID of the Geology app, has some kind of app role assignments over a different application, right? It has app role ID, this app role ID, right? Over the Microsoft Graph API, actually, right? But we don't actually know what this gives us, so let's look at that, right? What command do we use for that? It's a little bit a complex one because you need to know the app ID of the Microsoft Graph API, right? It's not really shown over here in this command. However, if you Google that, this will always be the same. The application ID for the Microsoft Graph API will be this, right? So what do we do here? We get the service principal of the Microsoft Graph API and list all the app roles that it has configured, right? And then we check which app role actually matches the app role ID that we are looking for, right? So let's do that. And then we will be able to see what permissions the Geology app has over the Microsoft Graph API. And if we see over here, the app role gives us policy.read.all over the Microsoft Graph API. And then the description tells us that this will allow our application to list information about the access of the policies of the organization, right? So I was going to say conditional access policies, but also some other policies that we'll see later on. But this permission also gives us access to read conditional access policies, which is something we will cover later. So as you can see over here, without assigning user, right? So this is not a delegated permission, this is an application permission, right? So we can conclude quite easily here that the Geology app is quite overprivileged, right? We went through some complex steps to enumerate this. However, in this specific case, we would also have a little easier way where we could have seen that we had the policy.read all permission, right? So if we just check our use the get mg context command, we will see that the scope that we have automatically received when signing into the Microsoft Graph API is a policy.read.all. Right. So here we could have also seen that, but it is good to know where it actually comes from, right? And we saw that is because of the app role assignment over there, right? So we will use these permissions a little bit later on, right? So let's go back to our slides. This was actually learning objective 3, right? So we enumerated the attribute-based access control on the storage account with the data analytics app. That allowed us to extract some secrets of the geology app, right? So the certificates from the geology app, we were able to extract that by modifying ABAC on the storage account. And then we enumerated the privileges that this geology app application has. So which Enter ID roles does it have, which Azure roles does it have, nothing, but it also has some application permissions, right? So it has Enter ID roles and application permissions, right? Let's go to the kill chain diagram to show it a little bit in more detail. So we added a tag on a blob in the old data store, right? Which was the certificate that was stored in there. We extracted that, and with that certificate, so with that certificate, the cert attachment X over here, we found that it is assigned permissions, or it is the certificate of the geology app, right? And the next, we also enumerated the permissions the geology app has. In the next learning objective, we will see how we will abuse all of these permissions, right? Because it is quite a lot, right? So let's quickly cover conditional access. We will not go into too much detail over here because most people already know conditional access policies, right? But for those that might not have that deep of understanding of conditional access policies, so conditional access policies uses signals to take decisions on a specific sign-in, right, of an identity, which can be a user identity, or as we saw previously, with the correct licenses, also an application identity, right? So what does that mean? So signals when you sign in as a user of an application, Enter ID will collect all kinds of information related to your sign-in, right? So that will be based on the user you are attempting to sign in as well as its group's memberships, the IP address from where you're authenticating, as well as the device platform, the device state, risk detections, all of that, right? So it will collect all of that information and use that to go over their conditional access policies that are defined in the organization, right? So go all over the policies, and it will see which conditional access policies should I actually interpret based on the signals that I have collected, right? And based on these signals, right, or based on the policies that it matches, it will actually take certain decisions, right? These decisions could be to block a user, right? So let's say we create a policy to that will trigger from a specific location. If that policy is hit, and the decision will be to block the user, then the user will not be allowed to sign in there, right? We can grant access, but just granting access without doing anything doesn't really do that much, because by default, if you don't have a conditional, if no conditional access policy is hit, it will by default allow you access, right? So what is more common is to have a grant conditional access policy with some additional requirements, like multi-factor authentication should be used when you're signing into this specific application from this location, for example, right? It can require to have a compliant device, right? Or quite a lot of other stuff as well, right? It might even ask you to accept terms of use, right? So these are some decisions that can be made, right? So Microsoft recommends using conditional access policies quite strongly, right, for good reason as well, right, because it is a critical part of their zero trust security model, right, and conditional access policies are actually very strong and they will stop quite a lot of attacks, right. Even if a user's credentials are compromised, conditional access policies can be very strong to block an attacker from signing in based on requirement of multi-factor authentication. But even if you use multi-factor authentication, it can block you if you're, for instance, not signing in from a trusted location that is configured there, right? So for an attacker, it is quite important to know about these conditional access policies to allow us to know which policies are in place and how we can actually bypass these policies, right? If we can know which policies are in place, we can try to see if there are any gaps in the policies, because conditional access policies can get quite complex. If you have dozens of policies configured, it can get quite easy to lose an overview of what is happening and what is being allowed and what is being excluded, right? So that is very useful for an attacker to take advantage of, right? So how can we enumerate conditional access policies? Sadly, as an unauthenticated user, you will never be able to enumerate that, right? You can try to sign in and you can see if you are being blocked, right? And then Microsoft will also tell you these are the signals that I am using and based on these signals, you are blocked access, right? So you will know when conditional access is blocking you after signing in. However, it will never tell you which specific, what is the actual reason for blocking you, right? So for an unauthenticated user, it's very hard to authenticate that, right? There are some tools available that will just try a lot of combinations of client IDs and user agents, for instance, to see if there is anywhere that they can sign into, right? But that is very noisy and it doesn't really enumerate the conditional access policies. It just tries to see if there is any gap there, right? So that's the only thing that's possible in authenticated, right? But even if you are authenticated, low privilege users are a comment is, I like how Microsoft strongly recommends conditional access for security, that makes you pay for it. Yeah, exactly. It's obviously something they want to make quite a lot of money on about as well, right? Especially for workload identities, right? So as an authenticated user, you will still not be able to enumerate conditional access policies, right? However, there are there is one exception to that, right? And this is actually fairly weird because there is one specific version of the AED graph API that allows very low privileged users, any low privileged user, to enumerate all the conditional access policies. Why? We don't know, but this version is called 1.61 internal, right? So yeah, it's an internal version. It's internal, but everyone can use it, right? Microsoft knows about it. They don't really do much about that, right? But it's the AED graph API. So this is the deprecated API that Microsoft says that they're going to retire in 2025. They have been saying that they will retire that for a while now, right? So for the time being, you can still use this API, but hopefully sadly for us as attackers, but luckily for organizations, this will finally be disabled in somewhere in 2025, and you will probably not be able to use this technique, right? We'll still show it briefly, but know that this technique will not be viable anymore for some time in the future, right? A lot of tools allow you to enumerate these conditional access policies as an authenticate or as a low privilege user, and they all use the 1.61 internal version, right? So Road tools, AD internals, and the other ones will all allow you to do that, right? But it's a basic get requests to this specific URL that you can see here, my organization's conditional access policies, and you just apply the version and it will magically provide you access to that information, even as a low privilege user, right? So what legitimate privileges do you need if you want to enumerate this the intended way, right? Or using the Microsoft Graph API, for instance, you will need quite a lot of privileges already, right? So, for instance, security reader, global reader, security administrator, conditional access administrator, and global admins will be able to read conditional access policies. This is probably not a role that you will usually encounter. However, if you compromise an application, for instance, with the policy.read_all or these other two permissions, then you will also be able to enumerate the conditional access policies, right? So recall, we have the policy.read_all with the Geo app and the lab over here, right? So we will look at how we can enumerate conditional access policies with that later on. And for the Microsoft Graph PowerShell module, you might need these other permissions as well, right? Okay, so conditional access policies, yeah, I think it might even be easier to show you what we can do with that. So we will look at that in the portal in a little bit, but yeah, it allows you very granular control over what you want to do specifically, right? So you can, for instance, require multi-factor authentication or block access to when sign-in happens, but only if you're signing into a specific resource, right? So you can go very granularly, make it apply only to specific users, only to specific resources that you're signing into, right? As we saw previously, right? And that brings us to learning objective 4. So let's quickly go to the portal and show you the conditional access policies once more. We went over this a little bit already, right? So let's just keep this brief. The policies are over here. So as we went over previously, you can either have workload identities of all users, but only workload identities if you have a specific license, right? And there you can go very granularly and say only specific users. This policy should only apply to specific users or specific groups, right? So let's select a group, for instance, and then you can even go more granularly and only say the specific policy should only be used when for specific applications, right? You can let that load where there are some other conditions that we can apply over there. Actually, it will take a while to load that, so let's not do that. So network, this is basically the same that's also configured over here under locations. It's new over here because they just moved it over there. But you can, for instance, say only apply this policy if you are signing in from a specific location, right? So if you see how we use this in the lab, there is a named location that we name student servers. And in this named location, we have defined the IP ranges of all the student VMs. So to only allow access to certain resources from the student VMs, right, and not from the internet, right? And that's something you can do with conditional access policies. Something very recently, recall with the first learning objective where we used device code authentication, the strongest way to actually prevent device code phishing is to create a conditional access policy where you target the device code flow without any other conditions, and then just select in the grant to block access, right? So then users will still be able to go through the conditional device code authentication flow, but once they reach the end, they will receive a block page and the user will never receive an access token, or the attacker will never receive an access token and a refresh token, right? So very strong. Right, and here you can require a certain type of multi-factor authentication. This is something that we will come back to later on as well. Okay, there are some session controls which you can, these basically allow you to configure a little bit more strictly what controls will be in place on a specific session after signing in. So for instance, if after signing in you want your user to re-authenticate after a specific amount of time, you can do that here as well. Okay. So let's continue with the learning objective, right? So where were we? Quick recap. We got access to the geology app over here, right? And we saw that it had quite a lot of entry-ID role assignments, right? So let's actually try to abuse some of these overprivileged role assignments that are provided, right? So we have help desk administrator, authentication administrator, and application administrator. When designing the lab, how did you collect the abuse cases worth covering? So that is, will probably be determined based on real life examples that we and Nikhil and other members from Alta Security have noticed during assessments, right? And as well as other common knowledge and just doing security research, right? So we want this. So obviously we don't want to have too much overlap with TCA or TP course as well. So basically a lot of things that we didn't cover over there or where we want to go a little bit deeper on, right? So let's continue. Let's actually abuse some of these permissions over here, right? So we have the help desk administrator role over a specific administrative unit, right? So we can reset the password, or Geology app can reset the password of users in this administrative unit, right? So let's see what this administrative unit, this one, this idea of the administrative unit, what this is specifically. So the administrative unit is called Geo App Managed, right? And let's actually list the members of this administrative unit, right? Just providing it the ID, and then we're listing the ID of the user and the user principal name, right? So we see that there are a lot of users in here. There's once again one user in here for every student. So storage mapper users in this specific administrative unit, right? So in theory, we can reset the password of all of these users, right? But one will be sufficient for us, right? So once again, the Geo app has help desk administrator on the Geo app managed administrative unit containing these users, meaning that the Geo app can reset the passwords of these users, right? So let's actually do that to actually give us access to one of these storage mapper accounts, right? As I'm student user 6, I will target student user 6. So to reset the password of a user, we first need to create a password profile variable, right? That contains a password and whether to force change the password on next sign in. We're going to leave that disabled. And then we are going to use a update mg user with the user ID that we want to reset the password of, the storage mapper 6 user, and the specific password profile will apply there to set that password on that user. If we would go to authenticate with this specific user with this credential, let's say we do some enumeration, we try to see what access we have, we are going to see that we will not have any access at this point in time just yet. We will not have access to any Azure resources. So to save some time, let's actually not do that, and we will use that account a little bit later on when it will have a little bit more privileges, right? So what else did the Geo app application had privileges to do? Right, so that's once again list the permissions of the Geo application. We also have authentication administrator on a different administrative unit. Let's keep that for a little bit later and actually look at the application administrator first. Right, so application administrator allows you to do quite a lot of privileged stuff over applications, right? For instance, it allows you to do add a password or a application secret to the application, or to add a certificate to that, allowing you to compromise that application, right? So you can think of it as the help desk administrator for applications, right? But there's only one application where we can have these privileges over, right? Actually, we assume that this is going to be an application because the application administrator role, but one useful thing that you can do if you have an ID and you don't really know what type of object it is in Enter ID, you can use the get mg directory object by ID command, right? So let's provide that with the ID of this object and see what kind of object this specifically is. And if we do that, we will see that this is an application as we expected, because it's the application administrator role. And this application is named XP Storage App SP. Right? If you already assumed that it was going to be an application, you could also just use get mg application with the application ID, and then you would see a little bit of the same thing. But so this is the information that we get, right? So application administrator allows you to add application passwords, right? Would the help desk account have the permission to reset a global administrator or other admin account? So this is a question that's being asked. No, it would not, right? So even if you look at the description, that is also always very helpful. It says can reset passwords for non-administrators and other help desk admins. So we can reset the passwords of other help desk admins, but not of admins, global admins and things like that. It doesn't allow you to do privilege escalation to global admin, sadly, or luckily, if you're a defender, of course. Right. So let's actually add a secret to the XP Storage App Service Principal or SP application, right? So for that, we need a password credential object, right? And we what information do we add in there? So here we don't really add a password directly, because Enter ID will generate a password for us directly. It will generate that secret, right? However, we need to provide some information like a display name and time for how long this will be valid for, right? So if you want to be a little bit sneaky, we can add the display name on something like this, added by Azure Service Bus, do not delete, right? And that might be enough for someone looking at this to leave that alone, right? And if you think that this is not realistic enough, we've actually seen that Microsoft actually adds this kind of things to objects and adds the do not delete in capital letters afterwards, right? So it's not that far-fetched to see that, right? And it will probably scare most administrators to not touch that, right? Unless they already have suspicion that something suspicious is happening over there. So we use that password credential to add an application password to the XP Storage App SP, right? So let's do that. And we see over here that Microsoft has, or Enter ID has generated a secret for us, right? So the secret will only be viewable once. So make sure to copy that, because you will never be able to retrieve that information again, right? So it just sets this one time and you are not able to actually view that anymore. So copy that. And now we will actually be able to authenticate as that application, right? Let's actually do that in a new terminal so we can keep track a little bit, right? So what did we do? We add an application secret to this application, XP Storage App SP. Right, so now let's actually authenticate with that. Fairly straightforward. We convert the secret that we obtained to a secure string, and we provide the application ID of the application to generate a credential object, and then we authenticate to our tenant as a service principal. to Azure, right? We do that and we see once again no subscriptions. That's easy resource. Now I did spell it correctly, right? And you see we don't have access to any subscriptions, so sadly nothing we can do with this application, right? However, we can try to see if this application has any access in Enter ID, right? Using the same credentials object. Let's authenticate to Enter ID or to the Microsoft API. And do the same thing, right? So let's list our service principal name of our user. And let's see if we have any access, right? In this case, we showed previously we showed two ways where an application can have permissions. So it can have Enter ID permissions, it can have app role assignments, but there is a third type of permission, if you can call it that, where an application will be able to do something. And something that you should always enumerate as well, right? Service principals can also own other objects, right? So let's see if our XP storage application owns any other objects in Enter ID, right? By providing it the ID of our application, right? Let's look at that. And it looks like we do, right? So we own a specific object in Enter ID. What type of object? A group. And this group is called storage access, right? So it seems like we have some privilege over this group. So let's actually look at this group a little bit further. So we can enumerate the details of this group by using the get mg group command. And we see that it has a description, right? So members of this group have access to a storage account, it seems, right? So it seems like if we add someone to this group, it will get access to a storage account. So since we own a group, right, the owner of the group will always have the privileges by default to add users to the group that it owns, right? So let's actually add a user to that group. Which user should we add? Well, we compromise the user of the Thomas user, right? But he's not really a good target because we don't really have his password, right? Another target user that we might want to add to this group is a storage mapper user, right? We recently got access to that and we reset the password of this user, right? So let's actually add that user to the storage access group. We get an error message saying that the object already exists. That's fine. That means that if you get that error message, that just means that someone else might have accidentally already added your user to that group. So that's nothing to worry about. It just means that your user is already a member of that group. So our storage mapper user seems to already have been a member of that group because I was testing this a little bit earlier already. So that's fine. The user is not now a member of that group, right? Which ID do we use? We use the ID of the storage mapper user. So how can we enumerate that, right? So we have our group ID over here for the storage access group. If you want, actually, this application will not be able to do that, right? Because it does not have the read permissions in the directory. The GeoApp application does have that permission, right? So we can obtain the ID of the storage mapper 6 user and then use that in our command over here to add that to our storage access group, right? And now let's actually see list the group members of our group that's called storage access with this ID. You can use the get mg group member to list the members of that group. And we should see that our storage mapper 6 account is a member of there. There will be a lot of groups, users in there already. So let's do some quick filtering with PowerShell. So let's list objects where it matches mapper 6. Right, so just to confirm, storage mapper 6 is in this group. Right. So now finally we will authenticate as this user. Right. So in this terminal we don't need the context of this application anymore. So let's just sign in as the user, the storage mapper 6 user, with the password that we had recently reset. Right. So this is the user we just added to the group. We connect to Azure. Connect Azure account, and we see we get a subscription. So this seems promising, right? Get easy resource. All right, seems we have access to 2 resources, all tab users and all tab key vault. Awesome. Let's actually try to list the role assignments, right? So we can see these 2 types of resources, a key vault and a storage account. Right, let's actually check which permissions we have over there. And we get an error message saying your Azure credentials have not been set up correctly. These error messages will change quite a lot, right? So a couple of months ago when we tested this would actually say you're not allowed to sign in over here because multi-factor authentication is required, right? And we don't have multi-factor authentication of this user. We only have the password of this user, right? But why is it giving us that error message? We can list the resources, so we should at least have read access. But when we're trying to list the role assignments, we get an error message, and here we don't get it. So that's very strange, right? Let's actually look at why that happens. We can do, for instance, dash debug. Now we can see some more information. We can see in the background what it's trying to do. If we scroll up a little bit, we see that it's trying to obtain an access token for the scope craft.microsoft.com. Why is get Azure role assignment trying to get an access token for craft.microsoft.com? I don't know. Probably it's gonna list some information for try to obtain some information from craft.microsoft.com. However, it is not really required for get Azure role assignment to do that. I don't know why they specifically request that. They will probably do something with that. But if we just want to see the role assignments on our resources, we don't actually need an access token for the graph.microsoft.com. So this is why we are not able to access that, because multi-factor conditional access policy is present that requires multi-factor authentication on graph.microsoft.com, but no multi-factor authentication is required on the ARM API. Right. So let's try to enumerate our role assignments directly using some API calls by only interacting with the ARM API. Right. So what are we going to do here? So we are going to list all the resources that we have access to, obtain an access token for the ARM API, because no multi-factor authentication is required there. And then for each resource, we are going to perform an API call towards the ARM API, where we are going to list the permissions we have over that specific resource using a GET request with our access token. And then we are going to list the permissions for each resource, right? So as you can see over here, no Microsoft Graph required to enumerate these permissions, right? So we have an access token, or we have some privileges over the all tab users, storage account, all permissions. We have read access over the management plane, but we also have read access over the blobs in there, right, over the data plane, right? And for the all tab key vaults, we also have quite a lot of permissions actually, some read permissions, but also the star read permission, so we can read the secrets as well from this key vault. Awesome. Let's try to see if we can read the secrets from this key vault. Right, let's try that. Get easy key vault secret from the old tab key vault. Let's try that. We once again get an access token, and we get no access token, and we get an error message, right? So we can use the same thing, do some debugging to see what it is trying to do. And once again, it's trying to obtain an access token for the Vault API, vault.azure.net, right? And multi-factor authentication seems to be required, so we cannot access the key vault, sadly. All right, so that is what we enumerated over here. So these conditional access policies requiring multi-factor authentication are being quite annoying, right? So let's actually try to see if we can see which conditional access policies are available and see if there are any gaps that we can abuse. Right? So remember, we're still signed in over here in our other PowerShell instance with the geology app user, which has the policy.read_all application role assignment, so the app role assignments over the Microsoft Graph API, right? So this one allows us to list the conditional access policies. So let's do that. We can use the getMG identity conditional access policy command. And we're gonna view the ID, state, and the display name of all the conditional access policies. So we see quite a lot of conditional access policies that are enabled. Always check which ones are disabled, because these will, you probably don't need to go into too much detail and do that. There can also be conditional access policies in a reporting state. That means that it will not be enforcing anything, but it will give the logs to the administrator to see how much times it would have been hit and things like that. Right? So we see quite a lot of conditional access policies, right? If we try to list some detailed information about these conditional access policies using this command, we will see we get not really much more information than what we did previously. We see that the conditions object will be some kind of PowerShell object, grant control as well, session control. So this is not really very useful to work with. We would have to do quite a lot of PowerShell filtering magic to get to the actual objects that we want, right? So that is what we meant with the Microsoft Graph module is not that ideal to work with always, right? Especially with complex objects like conditional access policies. It can be a little bit frustrating to work with that. Right? So what will we do instead to make it a little bit easier? Let's fetch that information and convert it to JSON with a depth of 5, right? And store that in a caps.json file, right? And then we have it in JSON, right? So let's actually show you that here we will have a little bit nicer output. So it's still JSON, of course. So it will not be that ideal, of course, but at least you will be able to see all of the configurations a little bit easier, right? So this is what we have. And let's actually open that file in the text editor. Right. So we saw there are maybe about 10 conditional access policies, maybe a little bit less, maybe a little bit more. So let's actually, to speed it up a little bit, we don't want to go over all of these conditional access policies, right? Because that would take quite a lot of time. So here we already know what we are looking for, right? We know that we are signed in to the user, the storage mapper user, and we added that to, let's show it over here, we added the storage mapper user to the storage access group, right? So this is what we did. So let's maybe see if the storage access group has a specific conditional access policy assigned, right? Because this storage access group was the one that provided us access to the OLTAP user's storage account and the key vault. However, multi-factor authentication is required here, so it's blocking us. So probably it might be, or we can assume that, we don't know, that it might be targeting this specific storage access group. So what we can do is actually search for the ID, just to show you guys where you can get that. So this is the ID that we will be searching for. This is the ID of the storage access group, right? So let's take that, search for that, and we see that there is one conditional access policy that is using this group as we expected, right? So we're making a little bit of assumptions here. We already know that, but let's say you go through all the conditional access policies and you get to this point where you see that this conditional access policy is assigned to, using this specific group in its conditions, right? So where specifically in the users conditions, there is an includes groups condition where this conditional access policy will apply on users that are a member of this group, right? And let's scroll down a little bit. We will see the display name of this conditional access policy. So this conditional access policy is named storage access policy, right? And let's see what else is configured over here. It will grant us access, but it will require multi-factor authentication, it seems, right? So this is what we are seeing. However, why were we then able to access the ARM API, right? If it requires multi-factor authentication for this group, there's probably something else that is excluding some kind of applications, right? If you scroll up a little bit to the conditions, under the applications, we see there are actually two applications that are excluded, right? So these are the IDs of the applications, right? The first one, if you will Google that, you will find that this is the Azure Resource Management API, so the ARM API, right? So this is why no conditional access was required when we are trying to access that. So then what is the second one? We have not found that one, right? So this, if you Google that, is the ID of the Azure Storage API, right? So it seems like for the key vault API required multi-factor authentication, but for the key vault, for the Azure Storage API, we will not require any multi-factor authentication, right? Awesome, so that's good to know because we saw that we had access to a specific storage account, right? To the OLTAP user storage account, right? If we scroll up a little bit, we see what's the kind of permissions that we have. We had read permissions over the blobs, right? So here we could once again use GraphSpy or PowerShell request towards the storage account itself. But here, since we are logged in with the username and password, we can just use the API, the PowerShell module itself from Azure, right? So let's actually create a new storage context, right? In the OLTAP users storage account, right? And then try to list the containers in this OLTAP user storage account. And what do we see? There is one container in here that's named tab users. No multi-factor authentication was required because it was excluded, right? In the background, this command will request an access token for the storage API, right? So let's actually, so we did that already, right? So let's not do that a second time. Let's list the blobs of the container now, right? So which blobs are in the tab users container in the storage account? Let's see, there's only one this time, and it's a blob named users.csv. So probably a file containing users and potentially even credentials in this specific case. So let's retrieve the contents of this blob and save that to a CSV file, users.csv. It already exists, so let's overwrite that. That's fine. We did this previously already. And let's now actually check what is in this file. Okay, so we see quite a lot of information over here, and what seems to be, if we scroll up, the CSV file containing passwords, IDs, and names of users, right? So, will you see this in a real-life example, this many users in the CSV file? Well, for the case of the lab, we have actually done this for the concurrency of the lab, right? So you can also think of this as the one credential being stored in there, but we want one user for every student there, right? But even in production cases, we see quite a lot that these files exist even for a lot of users at the same time, right? So it's not even that far-fetched, right? So let's actually filter this a little bit because we only want to see the records of our account, right? So let's do some filtering where the line matches user 6, for instance, and there are a couple that match that, but here we have exploration sync user 6. For my student ID, you will use your own student ID over here, of course, right? So these are the credentials for my exploration sync user, right? And we can probably use that in the next learning objective to continue, right? So this was actually learning objective 4 completely. So what did we do? We gained access to Geology app using the certificate. We saw that it is very high privilege, right? It has quite a lot of privileges. We were able to, with the application administrator role and ID role, add a client secret to the XP storage app. We were also able, with the help desk administrator role, over the Geo app managed administrative unit to reset the password of the storage mapper X user. And then the X storage app owns the storage access group, right? It owns the access group. So we added this user, storage mapper X, to this group, which allowed us to gain access to the OLTAP users and OLTAP key vault resources. However, multi-factor authentication was required for this one, but we found that conditional access policy exclusion was in place that allowed us to access the storage account API, which allowed us to read the container in there, tab user, that contained a CSV file, a blob entry for users.csv containing the credentials of exploration sync user X. Right, so that is what we did. Right, and next up we will see how we will abuse that. Right. All right, so before we take, or actually let's now take a 15-minute break and we will continue with the next learning objective after 15 minutes, right? So we'll be back soon. All right. So before we continue, any questions about the previous part? Okay. So if we have no questions, we will continue with temporary access pass. So in Microsoft terms from the Microsoft documentation, a temporary access pass is a time-limited passcode that can be. Okay, my microphone was not on and I was talking to myself. Any questions before we continue? Okay, I don't see any questions, so let's continue with temporary access pass. So a temporary access pass is a time-limited passcode that can be configured for single or multiple use, as described like this in the Microsoft documentation. Right? So a temporary access pass or a tab allows users to access their account without a password. Right? So you can use that as an alternatively when signing in aside from a password, right? And it will also automatically satisfy multi-factor authentication. So the tab itself is like a short password. It's going to be long as well. That will determine on the configuration that an administrator configures, right? However, it is not really intended to be used by users directly, as in a user, a normal low privilege user, will not be able to generate temporary access passes for their own account. So where is this useful for? Let's say a user forgets their password and or they are unable to satisfy multi-factor authentication because they lost their phone or whatever, right? Or you have a new user and you want to onboard that user, and instead of setting a static password to the start, you can, for instance, generate a temporary access pass for that account, and an administrator will then be able to, so only the administrators will be able to generate that temporary access pass for another account, and they can provide that to the user as a for temporarily signing into their account, right? So you can configure it that the tab is only valid for once, but it can also be used multiple times. But either way, it will be for a very limited time period, right? So this is to quickly get into your account, and then afterwards you can, for instance, configure your own password or reset your password, or you can, for instance, configure some multi-factor authentication method as well, right? So it's a means to get quickly back into your account, or an administrator can quickly generate that, communicate that with the user, and allow them to quickly sign into their account again, right? When a temporary access pass is enabled for a user, you will see that later on, when signing in with the email address, when you provide the email address of the user and the sign-in prompt, normally it will ask you for your password, right? When a tab is enabled at that point in time, the login screen will not ask you for a password, but it will ask you for a tab first before any other authentication method. Right? So even if a different identity provider, for instance, if you're using Federation, right, to allow your on-prem Active Directories to handle the sign-in, even then, temporary access passes will be preferred. Right? So it will not redirect you to your Federation sign-in page. It will ask for a tab, right? And this works across tenants as well. So how do you configure a tab? So to configure a tab, you need quite high privileges, right? So by default, temporary access passes are not enabled for any users in a ID tenant. You need to manually configure a policy to allow administrators to generate tabs, right? Only global administrators and authentication policy administrators will be able to enable tab, right? If you enable tab, there are some settings that you can configure, like the lifetime of a tab, right? Whether it is one-time use or only one-time use, or if it can be used multiple times, the length of the tab, right? As well as which specific users or for which specific users a tab can be generated. So that can be a list of users or a list of groups as well, and the members of these groups will be allowed to, or a tab will be allowed to be generated for those users, right? So only these two roles can enable tab or create a tab policy, right? Once tab is actually enabled, these are the roles that can actually generate a tab, right? So you can have global administrators generated tab, privileged authentication administrators, or other, if you have the user authentication method to read or write all API permission, right? Then you can also generate a tab for a user. Global readers or applications with policy.read.all can read the tab policy, right? So they can read the information, the configuration of these tab policies, right? But they will not be able to modify that, of course. Tab is enabled in authentication methods in Entra ID, is a question that's being asked. Let's actually show you that, right? Where do you enforce temporary access passes, right? So let's go to the authentication methods. To answer your question, yes, this is where it is configured, right? So if you go to the authentication methods, mostly you need very high privileges to be able to configure this. But we are signed in as a global admin, so we can show you that, right? So you will see by default temporary access passes are not enabled, right? But in this case, it is enabled for one specific group. So let's look at the configuration. What information can we configure? Zoom in a little bit. So we can configure a lifetime. So minimum, the tab is valid for 30 minutes, maximum valid for 1 hour. And by default, if you don't specify how long it should take, it will be 30 minutes, right? And it is not enforced to use it one time, so this means that a tab can be generated that is valid for multiple times. However, it will still only be valid for 1 hour, right? And this is the length. So these are the settings that you have over here. And for which users is it enabled? For all the members of the tab group, Entra ID group. For all of these users, a tab can be generated if you have the correct permissions. Right? The question is, can we read or can we query those values with the global reader role? The answer is yes. So if you are a global reader, you will be able to see the configuration. Right, so if you go back to the slides, this is covered over here at the bottom. Right. So how can we abuse this? Well, it is see it as more as a persistence mechanism or a stealthy way of gaining access to an account without having to reset the password of a user and without having to require multi-factor authentication, right? If you are able to compromise a user that has any of these roles, then you can basically generate a tab for any user for which it is enabled, and then you can sign into that account, right? And note that multi-factor authentication, if you sign in with the tab, it will also satisfy multi-factor authentication to a certain extent, right? So if we show you that over here, we go to conditional access policies. create a new policy. There is something that's called by the grants. So if you look at the grants and grant access, you will see that require multi-factor authentication is one check mark. So then it will just satisfy any type of multi-factor authentication. However, since recently, you are also able to select a multi-factor authentication strength, right? And these are custom policies that you can configure, but there are three default ones that are in there. So the most generic one is the multi-factor authentication. So any multi-factor authentication will satisfy this. So this is the same as just checking this box over here. But if we use passwordless MFA, it will only allow passwordless multi-factor authentication methods, and we also have phishing-resistant multi-factor authentication methods, right? So let's look at the authentication context over here. You can see that over here as an administrator. No, this is the wrong one. Authentication strengths is what we were looking at. Let that load. So here you can see these three authentication strength profiles. So if we look at the most basic one, you will see which type of multi-factor authentication methods will satisfy that. And here you can see temporary access pass is included. So a normal tab will satisfy multi-factor authentication. However, if you configure it more strictly than passwordless MFA, for instance, then only these four will be by default satisfy multi-factor authentication. So a tab will not work for that, and also not for the phishing-resistant ones. How long, the question is, how long are the tab authentication valid? These settings seem to be validity of the tab, right? Exactly, so let's look into that. That was our next slide. So according to the Microsoft documentation, they say that if you use temporary access pass to generate an access token and a refresh token and so on, the lifetime of these tokens will be limited to the remaining lifetime of your tab. So let's say you have a tab that's valid for 30 minutes. If you generate or try to sign in with that instantly, then Microsoft says your access token will only be valid for 30 minutes, right? Not longer than that, even if access tokens are usually valid longer. However, during our testing, we found that this was not the case, right? So we actually saw that temporary access passes, access tokens, are still valid, and you will see that in the tokens itself, the expiry date will be longer than the temporary access passes. And even when the expiry of the tab has even if we hit the expiry of the tab, the access token will still be valid, right, until the end time of the access token, right? So the tab expiry does not really seem to be enforced, even though Microsoft's documentation say that, right? So how can we abuse that? Let's say we generate a tab that is limited for, let's say, 10 minutes, right? We generate an access token for that. If we steal that access token from the user, then usually, if according to Microsoft, then that access token should not be valid anymore after 10 minutes. However, that is not the case because the access token will still be valid until it expires, right? Yes, indeed, you're still using the default lifetime of the access tokens if you use the tab, right? Unlike what Microsoft says in the documentation. That's what we are explaining over here. Okay, so we will look into tab a little bit later. One thing that we also want to cover are external identities, right? So external identities allow you to set up trust relationships between tenants, right? So it allows you to that allows users from one tenant to access resources in a different tenant, right? So either Entra ID objects or Azure resources, right? And there are a couple of ways that this can be implemented, right? The supposed scenarios are B2B collaboration. So this is what you will typically be familiar with. So if you create a guest or invite a guest user in your tenant, this will be using B2B collaboration, right? So a guest user will be created inside of the tenant where it is invited, right? And you will see that the membership type will be guest, and you can just assign it any permissions that you want, just as assigning it to a normal user, right? So this is enabled by default. Then the second type is a B2B direct connect. So think of this as your two-way trust on-prem, for instance. However, it works a little bit differently, so don't try to think of it like that as much, but take it with a grain of salt, right? So what happens is when you configure B2B direct connect, mutual trust will be created, two-way trust will be created, right? But external users are not visible in the tenant where, in the second tenant, they will only be visible in their home tenant, right? So obviously this is disabled by default. Otherwise, anyone could just access resources in other tenants, right? Without seeing those users there. So this needs to be manually configured, right? And then lastly, you also have Azure AD B2C. So this is mostly targeting customer identities, right? So if you are a business organization and you create an application, for instance, where you want your customers to gain access to and create accounts in that application, this will be using B2C, right? You also have multi-tenant organizations, right? So there it will just use a group of tenants to manage access, right? So, but there that will be for a multi-tenant organization that will be work a little bit differently. If you create as an administrator a new tenant in your organization, then you can use that as well, right? So where are these settings configured? These are configured in the cross-tenant access settings. I will show you that in a little bit in the actual portal, but let's first look at some terminology. So to understand what we will be looking at, right? So there will be a section called outbound access, right? And this will determine, this refers to when users from one tenant, from the current tenant, have access to resources in another tenant, right? So it's going outbound. Inbound is the other way around. Then it's another users from another tenant accessing resources in our tenant, right? We also have trust settings, so there we have a little bit other information that is configured. For instance, should we trust multi-factor authentication from the other tenant, right? So let's say we sign into our home tenant, and then we try to access some resources in the other tenant, right? Should multi-factor authentication be trusted from the home tenant, or should we enforce our own authentication a second time, right? Even if the user already did MFA in the first tenant, should we trust that, right? So if you set up a specific B2B collaboration, for instance, you can configure with a specific organization, you can configure that to allow the multi-factor authentication from the original tenant, right? Without having the user to perform multi-factor authentication twice, right? And other things also transfer, like compliance devices and hybrid devices will also be trusted from the other tenants. We will see we will see that in a little bit, these settings. That will make a little bit more sense, right? So there are a couple types of settings, right? So there are the default settings. So this is basically what applies when no more granular setting is configured, right? So the default settings are there are default settings, but you can configure the default settings to be something else, and then they're still called default settings. But this is what is being applied when you don't configure specific configurations for a specific tenant, right? So you can modify that. We will see that in a little bit, right? By default, in the default settings, B2B collaboration will be enabled. So you will probably already noticed that by default, users can invite guests in your organization, and then a guest account will be created there, right? But B2B Direct Connect is disabled by default. Cross-tenant synchronization. So this is another setting that we missed that. No. So cross-tenant synchronization, that's a different tenant setting. This allows you to automatically sync users from one tenant to another tenant. This is actually covered over here. Right? So cross-tenant synchronization allows you to automatically sync users from one tenant to another tenant using B2B, the normal B2B collaboration, right? So when you enable that, you can configure a group, for instance, and all members of that group in tenant 1 will automatically be synced to tenant 2, where a guest account for them will be created, right? So this makes it a little bit easier in certain cases where you always want a specific group of users to have access to a different tenant as a guest, right? We will see that we will be using that in the lab a little bit later on. One thing that we still need to cover is automatic redemption. So what is automatic redemption? This is basically a setting that you can configure that allows you to control whether any type of consent prompts should be shown when a user from tenant A tries to access resources in tenant B. Should consent be requested for when trying to access resources in tenant B or not, right? So it is a little more convenient to allow it to not request that consent if you specifically have a trust with a specific other tenant, right? So let's actually make this a little bit more tangible and look at that in the portal, right? So we looked at the temporary access passes. We looked at the conditional access authentication strengths. Let's now look at the cross-tenant settings, right? So I will actually show you where you can find that directly. Let's go to Microsoft Entra ID, then you know where you will be able to find that, right? So here we have the external identities, right? And then a little bit down here, we should have cross-tenant synchronization. So let's first look at external identities. And the settings for that are over here, cross-tenant access settings. All right, let's scroll down a little bit. So to make it a little bit more tangible, here we see the default settings and the organizational settings. So the organizational settings can override the default settings for specific tenants, right? Let's first look at the default settings. Right? So these are the default settings that will be applied when you don't specify any organizational settings for a tenant, right? So as we said, by default, the default settings will be that B2B collaboration is allowed for users and applications, and B2B Direct Connect will be blocked, right? And the trust settings will not be will also be disabled, right? So there are inbound default settings and outbound default settings. Let's look at the inbound default settings. So, all right, if we let it load a little bit, you can see you can modify the default settings, right? So by default, B2B collaboration is allowed. If you don't want that inbound to allow guests to be created in your tenant, you can block that, right? So let's not change that, but you can do that, right? Outbound it would be configured in the outbound access settings, right, where you would, you can, for instance, disable that a guest user is created from your tenant in another tenant, right? By default, B2B Direct Connect will be blocked, right? And trust settings, here we can see, for instance, if we want to trust multi-factor authentication from the other tenant, right? So if someone from another tenant is trying to access our resources inbound, will we trust their multi-factor authentication, right? And this needs to be already also configured the same way at the other side. Right? Should we trust their compliant devices, and do we trust hybrid joint devices from their side, right? So this will basically determine whether the conditional access policies will trust their multi-factor authentication or will it prompt that again, right? So these are the default settings. It's a little bit similar for the outbound access settings. We also have some tenant restrictions. Here we can have some additional restrictions configured, but actually it's not really covered that in too much detail, so let's not go into too much detail of that. What we actually want to see now are the organizational settings, where we can basically overrule the default settings, right? So we can see that there is a organizational setting for all corporation geology and all corporation reservoir configured over here. So let's look into one of them with the geology tenant, for instance, right? So there is some inbound access configured, or this is not configured, this is inherited from the defaults, right? So by default, B2B collaboration will be allowed and B2B Direct Connect will be not allowed, right? So this will stay the default. However, the outbound access settings, these are configured, so these are modified. So let's look at what is changed over here. For B2B collaboration, we're using the default settings. For B2B Direct Connect, we're also using all of the default settings. So what has changed? The trust settings we have configured to automatically redeem invitations with the all corporation geology tenants. Right? So consent prompts will be not required going to outbound applications in the all core geology tenant. Right? So this is what we have overruled over here. Right? Let's go back and now look at the cross-tenant synchronization, because this is what we will be using in the lab a little bit. Let's look at the configurations. And we see that there are some cross-tenant synchronization settings configured for the all geology tenant. Right. So let's look into that. What is specifically configured over here? This shows that all users that are member of the sync group in our tenant in all corporation will automatically be synced to all corporation geology, right? As a guest user, right? So the sync group, you can see that over here. There are some members in there, and these will automatically be synced to the other tenant, right? So all the exploration sync users will be synced to the other tenant, is what we see over here, right? All right. So this is what we will be using in the next learning objective, in learning objective 5. So let's look at that. First up, using the permissions assigned to the geology app, enumerate the tab policy on all corporation tenants and create a tab for exploration sync user. So let's see over here. Actually, let's just do it in the lab, and then we will look at the kill chain diagram a little bit later. So previously we got access to the credentials of the exploration sync X user, right? So that is where the previous learning objective ended, right? We got access to these credentials. So let's actually try to authenticate with these credentials. As you can see over here, these are the credentials that we found from the exploration sync user. Let's try to authenticate to our tenant, and we will see that we get a multi-factor authentication error, right? So multi-factor authentication is required to access that account, sadly. So we can sign into that even if we have the password of the user, right? So this seems to be it, and we could try to access other resources as well. Maybe try to connect to Microsoft Graph API, but we would see the same, all resources would be blocked and would require multi-factor authentication. However, recall previously, we're connected over here with the Geology app. There was, as you can see over here, there was still one thing that we have not abused yet, right? And that was the fact that this geology application still had the authentication administrator role over a specific administrative unit, right? So this is something that we have not abused yet, right? We have reset the password of a user, we have added an application secret, but we have not looked into that yet, right? But let's first look at the tab policies, right? So I showed you previously how you could authenticate that from the Enter ID portal. Let's now look at how we can authenticate that if we have the right permissions, right? So the Geology app recall has the policy that read all permission. So it can read the tab policies, right? So you can see over here, temporary access pass is enabled, right? So now let's actually look at the configuration of the conditional access, of the temporary access pass policy, right? And for that, you need probably the longest command in the Microsoft Graph module ever. Get mg policy authentication method configuration command with the parameter authentication method configuration ID. So if that is not long enough for you, I don't know what is. And if you use that command, you will be able to see the actual settings of the temporary access pass, right? So this is the same as we saw in the portal, right? Now just showing you how you can enumerate the same information, right? So default lifetime is 30 minutes, maximum lifetime is 60 minutes, and we can use it multiple times. We can also enumerate which group the tab policy is assigned to, or for which users we can generate a temporary access pass, right? Using this command. Get mg policy authentication method configuration. So this is the same command, but we are also looking at the include targets over here. So this was already returned over here, but it's a dictionary. So let's actually see what's in there. And we see that one group is enabled for tab. If we want to see the settings of that, we can just use get mg group ID, provided the ID. So this is the tab group we started previously. Let's now check the members. Member. And we get some IDs. Let's make this a little bit more readable, right? So yeah, you always have to do a little bit of PowerShell magic to see the actual properties that you're interested in, right? So here we will be listing the user principal name, which is in the additional properties attribute, right? So here we can see that all the exploration sync users are a member of this tab group, right? And also our exploration sync user 6, so that will be my account, to test over here. So what does this mean? This means that a user with enough permissions will be able to generate a tab for these accounts, right? So let's go back a little bit. We saw that Geology app still has authentication administrator role on an administrative unit, right? If we look what administrative unit that is, we will see this is the sync unit. And if we will check the members of that, we will see that these are also the exploration sync users, right? So that is enabled for the exploration sync users, and the Geology app has the correct permissions to generate a tab, right? So the authentication administrator role allows us to generate a tab, right? And it is enabled for the exploration sync users. So that's very convenient, right? You could have also enumerated this the other way around, right? You could have also just instantly checked which groups is the exploration sync user 6 member of. We could have done that instantly when we compromised that account, when we got the password for that account, and then we would have seen a little bit of the same information, right? So it's a member of the sync group, so it's automatically synced to the other tenants. We can see that's a member of the tab group, so tab is enabled on this account, and it is a member of the administrative unit, sync unit, right? Over which the Geo app application has the ability to generate a tab because of its authentication administrator role. So let's actually look at how we can generate a tab, right? So there are a little bit of configurations we need. Actually, that's not the right one. What will we be needing to configure when we request a tab? We can define whether the tab is usable once. Here we'll set it to true because you're only going to be using it once. If you want, you can use it multiple times because the policy allows it. Then the lifetime will be 31 minutes. Just it needs to be minimum 30 minutes. If you don't specify this, then it will be 30 minutes, right? And it should start from the current time, right? So this is what it will look like. Now let's create a temporary access pass for exploration sync user 6. Using the values that we've configured over here. It will take some time because it will need to do some stuff in the background. It will generate a tab, but it will also need to let the user know that if it, or at least needs to let Enter ID know that once a user signs in now, once this user signs in, it needs to request the tab instead of the password of the user. Right? So here you can see the tab, it's a randomly generated password. In our case, the policy is set to have it to be a password of 8 characters. You can increase that if you want. And what we can do now is go to portal.azure.com and try to sign in as the exploration sync user, right? And you will see that it will instantly ask for a temporary access pass. If you want, you can still sign in another way with the password and MFA, right? But now it will ask for a temporary access pass, right? Let's take the temporary access pass and sign into that account. And even though we previously couldn't sign into this account because multi-factor authentication was required, now we can access that because the tab does satisfy multi-factor authentication as well as a password. Right? So we are signed in to the tenant. Which tenant? We will see Oracle Geology tenant. Right? Let's actually see that. So the home tenant of this user is Oracle Corporation, but we saw previously we enumerated that it is automatically synced to the Oracle Corporation Geology tenant as well. So we can switch to our home tenant as well, but let's stay in at this one. Right. If we go to my sign-ins or my account from Microsoft and take a look at the security info. previously it would show up over here as when a tab was enabled. It would show you that in the security informed user while the tab was active. For some reason they changed that. It's not really consistent, but now if you go look at that, it will say that TOTP is in use, which is very strange because that's not a tab, but that's how it shows up right now for some reason. All right, so we are in the Corporation Geology tenant right now. What we can do now is take the access token that's currently generated over here. So one thing how we can obtain an access token from a signed-in session is if we open the debug window, go to the network tab and go to let's just list all the resources or the resource groups. It doesn't really matter. Anything with Azure ID will be fine, right? And you will see that in the background it will send quite a lot of requests, right? We are specifically looking for requests. This is a little bit small, but sadly I can't zoom in over here. We will see some requests to management.azure.com, right? Because it will list the resource groups and things like that, right? So in there, that will obviously be authenticated. You will see that an access token will be present, right? So there are some things that you can search for to find this easier. You can search for management.azure.com, or you can search for the API version string, because usually a request to the ARM API will contain the keyword API version, so this is what will be in the lab manual as well. Or you can just search for EYG0, then you will also see that it will show you all the requests with an access token, right? Because access tokens will always start with that because they are base64 encoded with some JSON data in there, right? So it will always start with it. Let's actually take a look at that access token. You will see that the access token was issued at the local time of this lab machine was 9:35, and you will see that it expires at 11:04, so about 90 minutes, even though the tab itself is only valid for 31 minutes, right, because we requested that. So you will see that at some point the Entra portal will say that your session has expired and it will sign you out. However, the access token that it is using will still be usable, right? So it will sign you out after about 30 minutes. As soon as it will try to obtain a new access token for any resource, it will detect that it's not valid anymore and it will sign you out, right? But the access tokens that were already requested will still be usable, right? So maybe if we continue with this, we will be able to show you in a little bit that we will be signed out over here and we will still have access with access token, right? So let's take that access token actually. Let's store that in a variable, our token variable, token. All right, and let's now connect to Azure with this access token. So we're connected to Azure, and we see that we have access to a subscription in the geology tenant, right? We specifically say which tenant we want to access because this is not the home tenant of the user, right? So let's see what resources we have access to. So we have access to two resources, it seems, right? We have access to a secure IAM web application website, right? And a geology vault, a key vault, right? I showed you that already. So let's go back to the slides and see that this is actually already learning objective 5, right? So we enumerated the permissions of the geology app and used that to create a tab or to look at the tab policy and see that we were able to create a tab for the exploration sync user. We were able to gain access to the second tenant using cross-tenant synchronization, and we were able to enumerate some resources over there, which we will be using later on, right? So this was actually a smaller learning objective, but let's see where we are. So exploration sync user 6 is a member of the sync group, right? Meaning that it is automatically synced to the other tenants. It's also a member of the tab group, meaning that the geology app is able to, or it doesn't really directly mean that the geology app can set a tab, it just means that the tab can be created for members in this tab group. However, the geology application itself is authentication admin over users in the sync units, administrative unit, making it possible to also generate a tab for this user, allowing us to sign in and gain access to the other tenants because of the cross-tenant synchronization. Right, so this is where we are over here. We enumerated some of the next learning objective a little bit already, but first we will cover some of the slides before we continue. Right. So what we specifically want to look at over here is PIM. So privileged identity management, right? If you are actively using Azure and working with Entra-ID, you will probably already know that because a lot of organizations are using this, but it's not used too often still, right? So because this is actually a very useful feature that allows administrators to gain just-in-time, time-bound, and approval-based access to Entra-ID resources, so Entra-ID objects actually, or roles in Entra-ID, and Azure AD resources through Azure roles. Right. So this is what PIM allows you to do. It allows an administrator to obtain a specific type of role, either in Entra-ID or in Azure, for a limited time period, right? So it will only be activated when the user actually needs that. And there can be some kind of conditions assigned to that as well, as we will see later on. So for what can PIM be used? For Entra-ID roles, for Azure roles, and also for groups, right? There are only a couple exceptions where it cannot be used. So classic subscription administrator roles, such as the account administrator, service administrator, and co-administrator in Azure, cannot be managed using PIM. However, these are deprecated either way, so these should not be in use anymore either way, right? But for all other groups, you can use PIM to gain access, temporary higher access to a certain type of groups, right? So activation of groups of roles require or can be configured to require certain conditions, like if a group is enabled, like if you're signed in as a user with normal privileges and you want to gain would, for instance, activate the authentication administrator role for something you need to do as a help desk user, you can force that user to perform multi-factor authentication before it gets access to that group, right? You can also require a specific conditional access authentication context. So only, for instance, if they are signed in from a specific trusted location, then it will gain that authentication context and the group will be allowed, right? And the third thing that you can enforce with privileged identity management is request some kind of justification or approval, right? So you can request the user that's activating the role to provide some justification in there, or provide a ticket number to link it to a specific change that needs to take place. Or you can have it require approval from someone else before the user gains access to that role. Right. You can also, if you do nothing else with PIM, it can also just be used to just obtain notifications. Right. When a specific role is activated, you can configure it to receive a notification so that you know that no one is abusing these types of roles for malicious use cases. If you see that it's being used at a specific time frame that doesn't really make sense and it's not really linked to a specific change, then it is a little bit easier to observe that when you have a notification set up for that, right? And lastly, access reviews can also be integrated into PIM, where some type of administrator user will need to periodically check if the provided access is still required for the users that can activate PIM roles. Right. So there are a couple of types of assignments that you can do in PIM. You can either be eligible. That means that a user can activate a specific role, but it is not currently activated, right? Or you can have an active assignment, meaning that this role is currently active and the user is currently using the role or the group membership that is assigned. Right? Both of these, eligible assignments and active assignments, can either be permanent, meaning that the user can be permanent eligible to activate it, right? However, it will not be active by default, but if the user needs it, they can temporarily enable it whenever they require it. It can also be permanently active, meaning that it will just permanently the user will permanently be using that group or role, in which case PIM might not be really the right solution. But why would you have something like this? Well, because it will still enable the access review, for example, right? And lastly, you can have it time bound as well. So meaning if you have a user that only needs to have or only needs to be able to enable the global administrator role for a specific amount of time, then you can say, okay, you can only activate this for the next couple of days until you are working until you are done working on this specific thing, or have it time bound completely active for the week as well. That can that's completely up to you, right? So how do we abuse this, right? We will see that yeah, this is actually very strong. So notifications can be sent in certain cases, but in a lot of cases, notifications are not correctly set up, and no one will know if you actually create or enable a PIN role, right? If it's also just asking for a justification and no one looks at that, then it's also fairly weak, right? However, if we compromise a user that is eligible to enable the global administrator role, then obviously as an attacker, we can enable that ourselves as well, or wait until the user enables it and then use that access, right? So let's look into two discrepancies that we found, right? So if we steal, and this is easier to demonstrate in this graphic, right? So if we steal an access token of a user before it has the PIM role enabled, and then we wait until the user itself activates PIM using either multi-factor authentication that we as attacker don't have access to, or some kind of approval is required, things like that. If the user activates PIM, the original access token that we stole before PIM was activated will still be usable and can actually take advantage of the new roles that are activated in PIM. So if you don't have the option to enable PIM yourself, but you have stolen some access token or have a refresh token that allows you to keep generating access tokens, you can just wait for the user to generate it themselves, because there will nothing be changing in the access token itself, right? So there will not be a specific claim in the access token that says that PIM was activated or anything like that. If you have an access token for the user and use that to authenticate to a resource, it's only at that point in time that it will actually check is any PIM active or not, but it will not invalidate other access tokens, right? So this is what we are going to showcase in Learning Objective 6, right? So first thing that we want to do is enumerate eligible role assignments for the exploration sync user on the open corporation geology tenant, right? So let's do that. And we actually already did that over here, right? So we are authenticated. We are also still signed in. I think our 30 minutes are not over just yet. So what we can do is, well, actually, what I maybe want to show you guys first is if we go to Enter ID. Let's close that so we can see a little bit better. We go to our feeds over here, view role information. Let's show you where you can see our PIM roles. We can see that currently our user doesn't have any active assignments. However, it has an eligible assignment for the group administrator, right? So we are able to activate this group. So let's actually try to do that. So we can do that over here. We need to go to the correct, come on. There we go, to the privileged identity management page. And then we go to my roles, where we can see which roles we are eligible for in Microsoft Entra. So it can also be used to gain temporary access to a group or to Azure resources, right? So we see that we can enable the groups administrator. So let's try that, right? This will take some time to load. So let's give it a second. Validating request. All right, there it is. Additional verification required. Click to continue. Okay, so if we do that, we see that this role requires multi-factor authentication in order to gain access to that, right? And we've tried, we don't have that, right? Because we have the password of the user. We also have the ability to generate the temporary access pass. Even though the temporary access pass does satisfy some form of MFA, when you're activating a role with PIM, it doesn't really like you using a temporary access pass. It will not accept it, right? So even if we generate a temporary access pass and provide it over here, it will not accept that, even though the access token contains multi-factor authentication claims. Or in this case, it doesn't. It contains step claims. No multi-factor authentication claims, but the tab claim is sufficient to satisfy multi-factor authentication, but not for this specific use case. Right. So we can't really activate that, sadly enough. So let's just go back to the portal. And I think about now, our tab will probably have been expired. No, we still have access. Okay, that's fine. So let's go to the Azure resources. Well, let's go to all resources. Do it this way. And we see two types of resources. Actually, at this point in time, we should only get access to this one. Later on, we will access that one. Right? So, Secure IAM is a web application that is configured over here. If we look at which type of permissions we have, we can click on View My Access. Do some checks in the background, look at what groups you are a member of, and it will show us that with the access to the Secure IAM users group, we have the reader role. So not that much, we can just read this application, right? However, if we go back to the overview, we see that this application has a specific domain. So always, if you get stuck somewhere during the lab, during the exam, or in a real assessment, right, and you don't really see any way to continue, check if there are any applications in use that are hosted in Azure, and if you can compromise one of these, you might be able to move a little bit further, right? So here we found through our enumeration that there is an application configured Secure IAM Azure website, right? So let's actually go to that and see what is actually what this application is actually all about, right? And this application will basically just allow us to test and play around a little bit with privileged identity management, right? So if we are over here, there's a Get Started button. It will ask the user to sign in. Since we are already signed in, it will allow us to sign in. And this is, just know this is a proof of concept application, right? You will probably not see anything like that in a real assessment. However, it's just to allow us to showcase a little bit how it would work, how the privileged identity management would work, right? There's simply a button over here. If you click that fetch access token, it will give you an access token for the user, right? So if we look at that access token, we see that the access token is for the priv user account, right? So for the priv user account for the graph.microsoft.com resource, right? We can see what specific access that this actually has as well by going through the scopes. But the most important information that we see here is that it is the priv user and it's for the Microsoft Graph API, right? So let's say this is a user that we compromise. We were able to steal an access token for this user, right? So let's go over here, assign that to a variable, graph access token. All right, and let's now try to authenticate to the Microsoft Graph API with that access token, because it's an access token for the Microsoft Graph API, so we can't really access anything else with that. And here we will be able to see that this access token is for the priv user, right? Okay, so let's actually see if we have any role assignments as this user. First, let's enumerate the ID of this user. And then you can use the previous command that we showed previously to see if we have any role assignments in enter ID. So it's going to all role assignments and filter on the ID of the user. This is taking some time, shouldn't take that long, to be honest. All right, that's all. And we see that we do not have access to any role assignments in Enter ID. Right. Let's see if we have any eligible roles, right? So there's nothing that's currently active, but maybe there are some eligible roles using PIM, right? So we see that the Enter ID role, groups administrator, the user is eligible for that, right? So it is eligible to enable that specific PIM role or that specific Enter ID role, right? Or it's not currently active. Question is, Microsoft is using, let's say Microsoft is using privileged identity management for a group, then permissions can be granted to the group. How can we check if the PIM for the group is assigned to a user? So how can we check if a user is eligible to activate a group? Is that your question? Yes, so this is what we did over here, using the get mg role management directory role eligibility schedule, right? So we see that the current user with this ID, the priv user, has an eligible role for the groups administrator. Oh, yeah, this is not, you're referring to the groups, right? So there will be directory, there will probably be command, actually, I don't know it from my head. There will be a similar command for that, right? However, I don't really know it from my head. I would need to look at my notes, so I'll get back to that after the session, right? But you can definitely evaluate that as well. All right, so let's continue with where we were. So we see that the groups administrator is what we are eligible for. So let's actually look at what groups exist in the tenant, right? Get mg group. Because we have the group administrator, meaning that we can add users to some groups, but which groups actually exist in the geology tenant, right? Because even if we were able to activate that, we need something to do with that, right? So there only seem to be two groups currently in the tenant, right? So you have geo admins and secure IAM users, right? So let's actually list the members of the secure IAM users group. And we will see that our user will already be a member of that. So we are already in the secure IAM users group. This group just gives us read access over the web application that allows us to enumerate that. So this is not really that useful for us, while the other one has admin in the name, so probably a little bit more useful for our specific use case, right? So what we can actually do is we can try to add a member to the GA-admins group with the group's administrator role, right? Let's try that. We will fetch the group name, the GA-admins group, its ID, and try to add a new member to that, and it will be our sync exploration sync 6 user, right? But we are currently not allowed to do that because the role is only eligible and is not currently enabled, right? We can also see that over here. If we go over there, no. If we go to PIM over here, And let's actually show the intra roles. The assignments is what we want. We can see that the pref user is eligible to activate a specific group, right? The group administrators group is not currently active, right? So if you look at the active assignments, the pref user will not be visible there. Microsoft is taking its time today. All right, so this shows the pref user is not even there, right? So what we can do now is, in this application, it will allow us to simulate a user who will actually activate PIM itself, right? So if you click the Assign Role button over here, this is just a proof of concept application, of course, right? So in a real scenario, a user would probably manually enable PIM, but it's just to demonstrate that. Previously, we got an access token, right? And we stole that access token before PIM was activated. And now if you click Assign Role button, it will take some time over here. The question is, can we activate PIM role using PowerShell when MFA is required? No, I don't think so. You'll probably not be able to do that because it will prompt for the multi-factor authentication. Right? You will see that eventually the role is assigned to the user. So if we now go back, we refresh this. In the active assignments, we should see that the pref user now has a group admin's Microsoft Entra ID role assigned. Right. So if we now try the same thing again, new MG group member with the same previous access token, we will get an error message saying that we are already a member of this group, right? But usually it should say, okay, successfully added to the group, or it will probably not give you any output. But this shows that we now have the privileges to do that, because previously it said we are not allowed to do that. Now it would have done that if we hadn't done this example already before this session. So we are already a member of that group, right? All right. We can, if you get that, if someone accidentally adds your user, we can quickly remove that, and we can add the user again. Right. So this is the output that you would be expecting to see. Performing operation, adding the member there, and no error message, right? So we quickly remove the user and edit it again for this proof of concept, right? And now we can confirm that by listing the memberships, the group memberships, with get MG group member of this group, that we are indeed a member of this group. Here we are, exploration sync user 6, right? All right. So now if we go back over here, we actually already showed that previously, but let's go to the resources. Remember previously where I said that we should not have had access to this yet? This was because we apparently already were in this group, but adding ourselves to this group would now show this geology vault, key vault, right? It was already visible previously because we did part of this lab already, right? But now we should get complete access to that, and we showed you how you could do that as well. And here we have it as well. We're trying to access the key vault, so it's probably going to be requesting an access token for the key vault API, and it will notice that the tab that we previously had is expired, even though the previous access token that we have, oh god, what did it do? Yep, we will have lost that access token. Anyways, the access token that we had previously will still have access to, you can try that later on during your own time, that you will see that access token will still be valid even though if the tab has actually expired. But for the sake of this example, let's actually generate a new tab policy, or a new tab, temporary access pause, for the exploration sync user 6 user. There we go. So we have a new temporary access pass. So now we will see how quick Microsoft actually is. Will it ask for the temporary access pass? Yes, it is. Sometimes it takes, it will not always be instantly, but this time it was. So we can sign in with the temporary access pass to once again get access to the key vault that we were trying to see, right? So let's go back to the geology vault. Let's see what kind of access we have. View my access. And because we are a member of the GeoAdmins group, right, which we just added ourselves to, we have the Key Vault reader user, but also the Key Vault secret user edgeable assignment. Right, so that means that we can read the secrets in this Key Vault. So let's actually do that. Go to keys. No, it will not be a key, it will be a secret. And there you have it. The oil secret is in there in that Key Vault. And if I would click on that one, you would see a secret value, and this will actually also be the final flag of kill chain 1, right? So if you go to the lab portal, you will see that there is a flag verification section over there, right? There will be a question where it will ask final flag of KC1. If you click on this over here to show the secret value, then you will get the final flag for kill chain 1. I will not show it over here. I will let you guys go through that yourself. Right. But let's actually go back, and we can see that we actually completed kill chain 1 completely. Right. So when did we start previously? We had access to the exploration sync user. Right. We had its password, but we couldn't really sign in with that. However, we could generate a temporary access pass for that user. Right. We could also, with that temporary access pass, we could actually access the secure IAM web app, right? Where we saw that the application allowed us to obtain a access token for Priv user and then activate the group admin PIM role, right? Which allowed us, the group admin role allowed us to add users to other groups, right? So we used that the privilege of group priv user to add the exploration sync user to the GeoAdmins group, right? Because we couldn't enable a PIM ourselves because of multi-factor authentication requirements, but because of the priv user having the group admin role, we were able to add the user directly to the GeoAdmins group itself, where we could now read the final flag in the geology vault. Right, so that was kill chain 1. Okay. Let's go back to the slides. And this is where kill chain 2 starts. Right. So as I mentioned at the start, we will go a little bit over time. We will cover one more learning objective, right? Learning objective 7. It's not that big one of learning objective. However, it is a very fun one, and it is a very, very powerful technique that we will demonstrate over here, right? So if you have to go in 10 minutes, that's fine. It will be recorded. And if you have any questions afterwards, feel free to ask them in Discord, of course. Right? So start of kill chain 2. Let's go through this fairly quickly, right? But if there are any questions, feel free to let me know, right? So as we already know, Entria ID applications are required to use Entra ID's identity and access management services, right? So an application registration, if you create that in Entra ID, that will allow you to use Entra ID features for applications, right? So without an application registration, you will not be able to, or your users will not be able to sign into that application, and the application will also not be able to query resources in your tenant itself either, right? So creating an application registration basically makes that application or allows that application to use all of these Entra ID features for authentication, authorization, and so forth, right? All right, so how does an application actually authenticate a user, right? So if you try to sign in with Entra ID to a custom application, how does it actually know which user that is signing in, right? So let's look into that a little bit deeper, right? If we use OAuth, then the application will obtain, once you authenticate, and ID will generate an access token for that specific application, right? And it will return that to the user, and the user will be able to use that to access the application, right? So how will the application actually know, based on that access token, who is actually signing in over there? Right. So it will look at the claims that are in the token. So as we already covered a couple of times, you can actually read all of the information that's in the access token, right? So the access token will contain claims. So these are basic facts about the identity who is signing in, so about the user, right? Which is also called the subject in this specific case in OAuth terms, right? So the access token is full of claims containing facts about the user. These facts can be, for instance, the user's email address, the user principal name, but also the roles that they have access to, right? But that all needs to be configured in the application registration. What kind of information the access or the what kind of information the access token needs to contain for the application to identify and that the user that's signing into it, and perform some type of authorization based on sometimes the roles that are included in the access token itself. Right. So Microsoft will by default put a lot of claims in there already. However, there are also some optional claims that your application can request your access token to contain, right? So these are optional claims that will be configured on the app registration itself, right? So on the app registration, the application can be configured to request certain types of optional claims, and if a user signs in to that specific application, Entra ID will know which claims to include, right? So for instance, the email claim is one of them, but also role and group claims can also be added to that, or any custom claims can be added in the access token as well. We will look at how this all looks in the Azure portal in a little bit, or in the Entra ID portal in a little bit, so that it becomes a little bit more concrete, right? So why are we actually talking about this? That's because of a fairly severe vulnerability that was discovered last year, or a couple of years ago. It was maybe already well known, but some additional research from some very good researchers had actually published a blog about this, where this was actually exposed that a lot of applications were actually vulnerable to this vulnerability. And this is actually NOAD, right? So Microsoft Azure AD, so this is from the NOAD blog. Let's see if we can show that. So in the notes you will see it's from dscope.com if you are interested to read that blog. They found that the email claim is both mutable and unverified, and they're saying that it should definitely never be used, therefore, as an identifier to authenticate the user. So what does that mean, right? Immutable means that it is not static, right? So over the lifetime of the account of a user, mutable claims can change, right? So things like an email address are not 100% static, right? A user can perfectly change their email address property in Entra ID, so it is mutable, right? Other properties like the object ID will always be static, so the user has no way to change their object ID. Like you can create a different user with a different object ID, but that will be a completely different identity, right? But for the email claim, for instance, you can change that um, on the same user itself, right? So therefore, that should never actually be used as an identifier, right? And what's more worrying is that the email claim is actually unverified, meaning that anyone can just modify their email address property to anything they want. It's not even verified. You don't need to prove ownership of that email address. So I can, for instance, change my email address property to admin@microsoft.com. Will I be able to send emails from that? Yeah, probably not, because DMARC and SPF records from Microsoft will block that, right? But the property can perfectly be modified, right? So if we have an application that is using the email claim to identify a user, right? And Microsoft puts the unverified email address of a user inside that claim, then we can basically become anyone we want, right? So this is what the Node application is looking at. So this is what we probably covered already. Yeah, sometimes you will also see optional claims having some sensitive information. So let's say, for instance, a claim is configured with a custom optional claim to contain a specific secret that is then used after the user authenticates to perform some second level authentication in the backend of the application. You will probably not see that often. It can happen, but it is very bad practice to do that, so you'll probably not see that often. However, the NOAD vulnerability in the last year, I probably saw it 2 or 3 times during an actual assessment. I also do web application pen tests, and I've actually seen quite a lot of applications where they integrate with Azure AD and they don't, or with Entra ID authentication. They don't know about this, and you can basically impersonate anyone you want. So yeah, remark from John. Indeed, you can send the email, but the recipient will not accept that because it will be categorized as phishing. Yeah, exactly. Indeed, if the recipient domain has DMARC policies set up correctly to not allow emails to be sent from any IP address that is not defined in the SPF record, then the email should be blocked by the recipient based on the DMARC policies, right? So that's what I meant with that indeed. All right. So let's look at how we can abuse that. Right. So let's say we find an application that is using Entra ID, is integrated with Entra ID for authentication, and we sign in with our Microsoft account or our company account, and we assume that the application might be using a mutable claim for identification. How can we know that for sure at the start? We can't really know. We can test for it, and if we see that it works, then we will know. But we can assume it, and this is if you do web application penetration tests as well, right? You should probably test for that if you see that there is an application using Enter ID. Is integrated with Enter ID for authentication. You should probably test for that, right? And you will be surprised where it will work. So, all right. So if we assume that a mutable claim is used, it can be the email claim, for instance. It can be other claims as well. This is just an example, right? Then we can, for instance, create a user or modify the email property of a user that we control to a username of a different user, right? And try to see if we can sign in with that. In a core application, it might even probably check if the email address of the user contains the word admin, for instance. Let's say your company has a specific naming convention where every administrator has the word admin in their word, and they have created a custom application that provides admin access to all users with admin in their name. This is not good practice, right? But this is the example that we will show. Then you might get administrative access to that application, right? So how do you defend against this? So the best one is to not use mutable claims, of course, right? So Microsoft actually recommends using, so you can use the subject claim. This is what the researchers recommend. This is what Microsoft recommends, is to actually use the a combination of the tenant ID. This will also be in the always be in an access token. So it will be TID, and the object ID, so the OID. Claims will always be in an access token by default. And if you generate combine these two, the tenant ID with the object ID, you will have a globally unique identifier because there will only be one object ID in a specific tenant that it will be completely unique, right? So, and it is not mutable, it cannot be changed either, right? And a user can also not set their own object ID to an object ID that's already accessed, for instance. So it's not possible to take over an account of some other user, right? Note that when this research came to light in June 2023, Microsoft made some changes because this was very, very dangerous, right? So now for new applications created after that, or applications that were created before that but had never seen a sign-in attempt from a user with an unverified email address will now not contain, so if you sign into an application that's newer than June 2023, or an application that has never seen an unverified domain in any email address previously, then it will automatically be configured to not include the email address of unverified domains anymore in access tokens, right? So for older applications where there were in the past sign-ins with unverified domains, or if you manually overridden that to still include the email address, those will still be vulnerable, right? For newer applications, Microsoft will actually check if the email address that's being presented there is actually from a verified domain. What does that mean? That means that you, in your Enter ID tenant, that you have verified ownership of the domain. So an attacker can't, for instance, use the email address of Microsoft.com. They can still set that property, right? But it will not be sent anymore in claims and access tokens. Right, so that is what has changed for newer applications. So in the lab, we still have a vulnerable one that we will be abusing, right? So this is the last learning objective that we will look at for today. So let's do that really quickly, right? Actually, let's go to the Azure portal first, where we are signed in as the administrator. And let's go, first, really quickly, show you the app registration itself. So if we go to registrations, we have one over here, the Node app, L applications, Node app. All right, so let's look at the authentication. So this is where you can configure your application to request specific type of tokens that you want to receive, right? So in this case, if a user signs into the application, an access token and an ID token will be returned that the application can use. But what we specifically want to see, no, this one above that, the token configuration, right? So here, some optional claims are provided, right? So both in the ID token and in the access token, the optional email claim will be returned, right? So it will return the email address of the user if it has one configured, right? So let's quickly show at that. So let's say we want to add an optional claim in the access token. These are all the optional claims that we can include. Right, so let's say we, for instance, want our access token to contain the password expiry date of the user. Right, for some reason, if our application needs that, or it can check that. For instance, if you have an application that wants to show a notification, hey, your password of an ID is expiring in 3 days, for instance, it can get that information from the access token, for example. Right, there's probably better ways to do that, but it can get that from the access token as well. Right, and there are also group claims. So you can have security groups, for instance, that will be included in the access token or in the ID token, and you can provide which type of um, format that they will be used, right? So by default, it will be the group ID of the security group that will be listed in the access token, right? So then it will list all the group IDs that the user is a member of. Very useful if you want your application to do some authorization checks, right? All right. So that is what I wanted to show you over here. So now let's actually go to the application itself, right? So if we look at the learning objective, there is a known application that we found. So in a normal scenario, consider this that you find this during after your enumeration phase, you find the drill planning application, right? And you find that it is linked to your target organization, in this case, oil corporation, right? So you find that we need to sign in with an account over there. So let's try to sign in with Microsoft. Let's try to sign in with a wrong account. Let's close that. Go to that in an incognito window. So let's try to sign in to this application. So with which user do we want to sign in with this? To this, let's try to sign in with our attacker email address, right? So in case this is a multi-tenant application, we can check if it allows any user from any organization to sign in. So we can check that. student6@normalall.onmicrosoft.com. So this is our attacker tenant, right? Everyone has an attacker user. So consider this as your attacker tenant, which you have full control over. So you will be able to modify all properties of this user in your own tenant, right? Let's sign in with that. You want to stay signed in? Sure. All right. And it seems we're already an administrator. That's not good. Let's actually go to the portal. So in the attacker tenant, let's go to enter ID. Let's search for this user. There we go. see the properties of this user, and let's actually modify these properties. So you will see that we will already have changed the contact information over here to admin student 6. Right, so in this case, we already know that the application is vulnerable. If you were testing for this in your own for your own applications that you don't know that are vulnerable yet, you could try to see what kind of properties you can modify and if that has any effect on the application, right? So let's actually sign out over here. Just to show you what it should look like initially. So student 6 add no more all. Let's try to sign in as that user one more time. And then after that, we will need to sign in once again, right? Okay, so here we see we are currently not an administrator, right? We get access to the application. We see that it somehow got our email address. So where did it get this email address, right? Probably from the access token, right? The email property in the access token will have shown our email address to the application, which allowed this to know that this is the user that signed in. We get some basic functionality over here. It's just a demo website, so there will not be too much on there. So here it says, please use your work email as your access is determined based on email ID. So this is already a little bit of a clue that that the access will be checking the email address, right? So if we can go back to here, and you already saw how the process goes, but we know that this application is actually vulnerable to NOAD because it will look at the email property and check if the user is an administrator. Know that this is just a very, very basic example, right? You could try to, for instance, change your email address property to student. For instance, if you know that there is a user named Alice in the target organization, you could try to do that as well, right? And then you would get access with the privilege of Alice if this is what the application is looking for. Note that the email address is allcorporation.allmicrosoft.com, not no more all, right? So we are setting the email address to something that we don't even own, right? So as I said, you could do this perfectly fine, right? No one would check this. You would not be able to send emails from that, but no one would actually check that. Right? So let's change that back. Student 6, and then student 6. Save that. And we can see that our property is perfectly modified, as we can see over here. So one last time, right? Let's sign out. Come on. Log out. And sign in again. You will see that the access token that the application received now will contain the admin student6 at all corporation email address, as you can see over here. See, so this is a clear indication that the email claim in the access token is used by the application to determine which user is signing in, right? Actually, it is still showing the old email address. That's because there will probably also be a user principal name in there. And for some reason, the application is using the user principal name to display the name over here, but it is still using the email property to check if the user is an administrator, right? So here we get access to the admin panel over there, right? So the question is what JSON Web Token field shows the email claim. I'm assuming it's separate from the field that's your actual user principal name will normally be in. That's right, it will be, as we saw over here. The claim will literally be named email, so there will be a claim in there named email, right? But even if the application is using user principal name for authentication, then this would be vulnerable because the user principal name should also not be used for that, right? So if you go to the documentation from Microsoft, it will actually say never use the unique name and the user principal name for authentication because this is also mutable, meaning that this can be modified, right? There are ways to influence this property as well. Right? So the example to show with the email claim is fairly basic because you can easily change that. User principal names are a little bit harder to change. However, there is a setting that you can enable to where you can allow access tokens to contain the let me show this in the tenant. That will make it a little bit easier. So in the properties, you have the email address claim over here. You also have other emails, right? If you add something over here in other emails, this will be added to a property of the user named proxy email addresses, right? And there is a setting somewhere. I'll try to see if I can find it for you guys. But if you go to Microsoft Entra Connect, it's at a really weird place, but that should be there. Configuration, yeah, that's what I thought. Let's show it in this tenant. I have a feeling this is not the right place. Let's let it load for a second now. So it is here, but it will be there. All right. There is a setting over here that you can enable where email will be allowed as alternate login ID. That means that everything in the proxy email address property will also be allowed to allow you to sign in with that email address. If you enable this check mark, you could configure a user, this other email address property, and that email address, it can be, for instance, admin@microsoft.com. You can then use that to sign in to your own tenants, and Microsoft will map that to this specific user, right? But if you then look at the access token, it will take the email address that you signed in with, so that could be admin@microsoft.com, and it will put that as user principal name. So that is why you also should never use the user principal name field, because that can also be influenced, right? So the one with the email address is actually a basic example. The one with the user principal name goes a little bit further, but that specific technique, I found that a lot of applications are actually vulnerable to that because they expect that the user principal name in the claim will always be this one that the user will not be able to forge, right? All right, so where were we? We got admin access to our portal. There is a button over here that says Add User. So let's say this is a custom application from Oil Corporation that's where administrator users can sign into to provision new user accounts, right? This is a perfect legitimate example that we have seen already at clients as well. They create some custom application to make user provisioning a little bit easier, sometimes even allow HR to create new users if someone new is onboarded, right? So that IT doesn't need to be involved in that every single time, right? However, it's also a little bit for to make the lab a little bit to transition a little bit easier into the next learning objectives. So we have an add user button over here. You will see it will take some time to load, and basically what is happening in the background, it will send a request to a logic app that will automatically create a new user account with a random name. It will also start with a build planner and then a random name and a random password. Right? So let's copy these details actually and use that in the next learning objective, which we will cover later on, right? Because I'm just copying these details for next time. Let's look at our slides again. We will see that this was actually completely learning objective 7 already, right? So we access the drill planning application as the administrator user, right? So first as the student user, then we modified email address and we saw that we had higher privileges, and then we generated a, um, a new user with that. So let me show you Gilchin 2. Let's open that in Paint. So kill chain 2, as we said, will start completely separately from kill chain 1, right? So we got a new initial access technique using the NOAD attack that we found that the drill planning application was vulnerable, right? So this will trigger a logic app in the background. You will not see that, but this is what it will do in the background. It will create a user, well planner X, that it will then show to the user, and then we could sign in with that later on. But that is actually part of the next learning objective already, right? So we will go over that in the next session next week, right? Are there any questions about anything we covered this time? Do you have resources concerning the cost reduction and expediency of setting up an attacker tenant in Azure? So an attacker tenant, um, you can actually, if your organization allows you to do that, you will also be able to generate, set up a demo or request a demo tenant from a demo enter ID tenant from Microsoft, right? What you can also always do is if your organization has not restricted that for you, um, let's see where we are. Create your own tenant. So tenants on its own, at ID tenants, do not really cost money if you don't really assign any license to that. You will be very limited to what you will be able to do with that, but you will be able to create a new tenant, right? Where is the setting for that? At user, there will be here it is. Manage tenants. You can create a new tenant over there, and you can create an Enter ID user, right, and modify its properties there. So you will by default become global administrator in that tenant as well, right? There you will be able to create some users to perform the NOAD attack, for instance, already, right? Yeah, you can also create a trial license indeed. All right. Any other questions about anything we covered right now? All right. Yeah, no problem. Awesome, thank you. All right, so if there are no more questions, then I will see you guys in the next section next week, where we will start with going over the Azure Logic apps. Right. In case there are any questions during the week, feel free to ask them on Discord, of course, and we will go into detail of that. Right. So thank you everyone for this session, and I see you guys next week.